Alright, now that our P1 incident is closed and we will do our CA later, thanks a lot. Once again, welcome to Wayfair and the 53rd LSP Meetup. Great to have all of you here on a Saturday. I am a staff engineer with the Wayfair Platforms Group, and on behalf of Wayfair leadership, very happy Saturday and a very warm welcome to all of you. Before we start, quick round of applause to the team that basically resolved everything. We all have been there, we all know how amazing it feels to basically resolve the issue, get the show back on track. Right. Just a quick introduction about Wayfair. Relatively newer in India as a PDC, though we are definitely not a new player in the market that we work with. We are an e-commerce platform exclusively focused on home. And we all know that when we do homes, it's a very personal decision, it's something that every home that we have been able to carry is part of our personality, a part of who we are, and that's what we look to kind of facilitate via our offerings as such. Right? We're a network of more than 20,000 suppliers, more than 22 million active customers. We are a platform-first company, which is our build the technology, build the infrastructure in order to make sure that our supplier services run at scale, our customer service is impeccable, right? Our fulfillment pipeline is state of the art because we know certain names that are pretty good at that game, right? And then the most important thing every time you venture into the segment, and most importantly in a segment like home, which is very personal, is the shopping experience. Anything and everything that we build on technology and infrastructure is meant to power these four key pivots that we have. Now, quick fast facts. Like I said, this PDC and Wayfair is relatively newer in the country, but then again, the countries and geographies that we operate in, with our business, we're definitely not a newer name. Right? The world's largest players in this particular segment, which is home retail, right? Some of the numbers on the slides speak to themselves as to what our scale, what our reach has been, more than 20 years old as a company, right? In terms of business, very focused on the Neymar and the European region. As of today, that's where most of our business operates, right? A lot of folks here would essentially be tempted to ask a question that we used to ask for certain retail companies a few years ago, but that we can obviously talk about later. In terms of technology footprint, multiple geographies, multicultural, very multi-diverse set of crowd that we have. As you can see, Bangalore is one of the newest centers that we've had. It's been very close to now being 2 years old as a TPC. We've grown. I think the TPC started with a handful of people. We started off at a WeWork in Embassy Tech Village. Now today we are 550 plus and growing. Right? That's where we are. So that said, very happy to have LSP come join us today and to kind of share all the cool stuff that all of us are doing. And without further ado, because I know we're already running behind, we will not be holding it back anymore. So the first talk that we have is from Gaurav around how we do large-scale deployments at scale. Large-scale deployments without really trying to go and burning the house down, making sure that our services are interrupted. So let me just call upon Gaurav and hey Gaurav, come on in. keep it on. Let's keep it on the side because people will need it. And this will need power also continuously. It cannot go down.
Are you sharing it? Can you manage with this, please?
Hey guys, so let me just introduce myself. My name is Gaurav. I'm a software engineer in modern employee team at India. I've been in the industry for almost a decade, and I'll keep my introduction short. So just like Mr. Wood in Pulp Fiction, I solve problems. So moving ahead, as Vishnu already told, Wayfair is in e-commerce business. We generally sell furniture and other home furnishing items. We have 20,000 plus vendors. We have 22 million plus customers. And unique thing about us is like we don't maintain any real inventory. We just meet the customer's demand with the suppliers, vendors supply, and we take care of what comes in between. We have our own platform. We have logistics. We take care of customer experience. We take care of all the support. So, given the amount of traffic, given the amount of user base, given the amount of vendors that we have, our scale is pretty big. So, in that big scale, I'm going to tell you like how we generally do last-stage deployments and what issues we generally face. So, yeah.
600 billion is per day for alarm, like what is it?
So it's the total number of requests that we have served in last year.
Okay, so cool.
Okay. So basically, what's the traditional way to actually deploy any kind of application or just to develop a particular feature? So what do we generally do is developer will get some requirements, he'll work on that feature, he'll test it in its local, put it in production, and if it works, it will be there. If it doesn't work, we will roll back. Simple as everyone knows. But let's just say it doesn't work after some time. It can happen depending on service growth or traffic increase or something else broke, and we have to roll back everything from the production. Rollback may take a lot of time depending on the process. It can be a tedious process where you have to build an entire image, push a new commit, push a new change, or it may be as simple as like, okay, just roll out the previous image that you were using. But what we needed was even more simplistic approach where let's just say a single particular feature is in, and what we want to do is we just want to switch off that particular feature, okay? And because this particular feature is not working, let's just switch it off and done with it. So what we wanted is a feature cover system. So a feature cover system is on basic level, what I can say is like, let's just say a developer has to write simplest API to add any particular user system. So before that API or before this function, before the actual logic, we will just put a if condition, check if this feature is enabled, that code block will execute. If the feature is disabled, that code block will not execute. And to check if the feature is enabled or not, we'll call an external system where you can control whether to enable the feature or whether to disable the feature. And that way you can even control in any environment as well. And if we go even further, like we can even granularize it on the user base level or segment level or anything. But let's just, for the simpler terms, let's just keep That's a feature toggle system. So what we did is we came up with an in-house solution. We built, so we have a monolith application written in PHP, and it's deployed on multiple VMs. And there we have written a small piece of code in PHP, a monolith system, where user can add a new feature, user can update that feature, enable that feature, disable that feature, and our the code base will actually just check whether the feature is enabled or not, and then it will deploy to production. Not necessarily because the deployment has already happened. We can just flip the feature on the fly. This was pretty much good till like we have low traffic or less adoption. Initially, everything was fine. Initially, everything was like okay, we have one particular feature. We can just switch it on or switch it off any point of time, and if there is a bug, we can just flip the toggle off and everything will work. So, what challenges we actually face in this current approach? Basically, the moment adoption grew, more and more users came in. So, by users, I meant developers. So, when developers started using the feature toggle in its code base, we have like thousands of toggles in one particular system, and it was not manageable. We didn't have any functionality to segregate the feature toggles. There were like a single panel where all the feature toggles are present, and there is no way to segregate like which particular feature toggle belongs to which particular project or which particular section of code. So it was pretty much messed up. Yeah.
I have one question.
Yes.
Online. The feature checking happens in the app or externally?
So it happens inside the code base only. You can control it from an outside some sort of system, any application or any server, but the check always happens inside the application. And it's a continuous pool. Say every 30 seconds, 60 seconds, you'll update the feature, and after 60 seconds, it will be reflected in your code base. Okay.
One thing over here.
Yeah.
You said the code base, the app is deployed.
Mhm.
We continuously poll the central feature system,
Yes.
the flag system,
Yes.
whether it's there or not. Won't it get a lot of load on the flag system?
Yeah, I'll talk about that.
Okay, sure.
Okay. So the moment more users increase, more adoption increase, number of feature toggle increase, number of requests also increase, traffic also increase, the queue facing a lot of scalability issues, maintenance issues. Whenever we have to do some sort of update, we have to it became a P1 application, because whenever we have to do any kind of maintenance, the system has to go down, we have to take downtime and all. So we face a ton of challenges. There was no tracking as well. Whenever a developer has enabled a feature toggle or disabled a feature toggle, there was no audit why the developer has enabled this particular feature, why he has disabled it. There was no idea. Sometimes developer was even confused, like they were just searching for a feature toggle and they thought, okay, this might look like my feature, but it may not be. There are like thousands of features and not sure which one was which. So a lot of problems were there. Things started to like become a nightmare when we started decoupling our application. So, as I mentioned, ours was a monolith application, and as the industry grew, as the user traffic grew, we have to decouple our application into smaller microservices. Now, smaller microservices can be in Node.js, Java, Python, any language, and it will be deployed in some other server, in some other repository. The code base will be different. And our feature toggle was written in PHP in the monolith repository. So there was no way to check or to fetch the value actually. So we came up with another service, Purist service, which actually exposes API to fetch the feature toggle and we exposed it to multiple microservices that we were using. And it became even more maintenance overhead because now we have to maintain a web server as well, which will expose the feature. And the maintenance overhead just grew by every second. Now, in all these fires, what we decided is like, okay, we have lots of problems. Let's just dump all of our problems to someone else. We came up with there's a third-party application, Unleash. So we thought, okay, we will focus on how to meet our customers' demands and our suppliers, and let Unleash focus on the feature development. So Unleash is a third-party vendor. They mainly focuses on how to develop a feature toggle system, and we used their feature toggle system to maintain everything. Now, their system is much more scalable. They have project level segregation. We can also tag all the feature toggles to identify what feature toggle actually does. And let's say a feature toggle is created and created by some developer, the developer left the work. The next employee that joins, he don't have to go through entire journey or go through some dogs or why this toggle was created. He can easily identify this project, he can easily identify the toggle by the tags and identify, okay, what this feature toggle is being used for. There is much more access controls, user-based controls. So a user is, and not every user is allowed to flip the toggle of any project. Not every user is allowed to create a feature toggle. Not every user is allowed to create the project itself. So there are granular controls, and one of the best things that we like about that product is they have activation strategies. So on the activation strategies is something like, let's say I have 20 million user base, but I don't want to expose a particular feature to all of those users. I just want to test out my feature with just 1% of users. So I can roll out my feature on basis of percentage. Okay, let's just expose it to 1% of users or 2% of users and see how general users react. We can also select the users geographically. We can also select the users based on a specific category. We can categorize the users, and based on that, we can activate our feature flag so that it won't be available for each and everyone, which was a great functionality to have and we love. So this is how our new architecture actually look like. So basically we have multiple microservices, we have monolith VM, they connected with our Unleash server, and Unleash server had all the feature toggle in PostgreSQL database, and we were able to fetch the feature toggle, update it, and do anything. Now, when we look at this particular architecture, everything looks good from the maintenance side of things. We don't have to manage the code base. We don't have to build, the feature toggles are much more manageable, much more segregated. But when we think about the user traffic, then it creates a problem because reading a feature toggle from a cloud SQL or from any kind of database is much more heavy. So whenever the more number of read requests we send, the more traffic we face, more issues we face. Now to solve this issue, what we did is we came up with Unleash also provides another service called Unleash Edge. So what Unleash Edge does is Unleash Edge keeps all the feature toggle in its memory, and it will asynchronously pull all the feature toggle in its own memory and serves the request. So we redirected all the read queries on Unleash Edge to handle the amount of traffic, and kept the Unleash main server only for update purposes, or to create a feature toggle or manage the feature toggle. But all the read requests will go to Unleash Edge. Now, since ours major sale events. During the sale events, we expect a huge burst of traffic. To handle that, since Unleash Edge is a stateless service, it keeps all the toggles in its memory. What we did is we deployed everything in Kubernetes environment. We enabled SDA based on the CPU matrices and everything as the user traffic grows, the release points can scale up. As the user traffic decreases, the release points can scale down, and everything will go simple. Whenever a release point comes up, or the next point comes up, it will always sync on the feature toggle with the new service. So that may take some time for the readiness. To reduce the time, what we did is we introduced a Redis cache where whenever a new pod will come up or a new pod, Unleash pod goes down and a new pod is spin up, it will load all the toggles from the Redis cache itself. It doesn't have to create more load on the Unleash main server. So, till here everything looks good. Our maintenance issues are gone, our manageability issues are gone, and a separate third-party service is handling our services, and load is also managed, traffic is also managed. Yeah.
Would this be like too much reliance on a third-party instance where all your features are configured?
So it's not all the features are there, it's just feature flags.
Yeah.
And feature flags is.
What if the third-party was?
So the third party, the infrastructure is with us. We are just using their image. So the code base is in the third party, and they have provided us the image, and the infra is with us only. So everything is on our control only. And if we talk about like, okay, it's possible that there might be some sort of security concerns. So as I mentioned, these are just feature flags. Just the name is on the post, the feature name, and it only contains true and false. Not a security concern, and data is with us on infra.
So, what's the tech stack you use for observability?
Sorry?
The tech stack you use for observability?
Okay, so I'll also come on that later. So till then, everything looks good, but no. Actually, the thing is like, since at this point of time, our adoption of feature flag through humongous. We were receiving somewhere around 18,000 requests per second, which is huge traffic. So, and on 18,000 requests per second, if we talk about like latency, we are getting somewhere around 15 to 16 ms on P90, 21 ms on P95, 33 ms on P99, and 40 plus milliseconds on P99. When we look at these metrics, these looks really good. 30 ms millisecond P99 latency on 18,000 requests per second is good. But when we, let's just say that there's a developer and he added 10 different feature toggles in a single page request. Now 10 different feature toggles are being called, and let's just say it created 300 milliseconds of page load time. And let's just say it's just P99 latency. That means only 1% of users might be facing this issue. Now we do the math of 18,000 requests per second. So 1% of requests will be like 1.8k requests per second, and 6.4 million requests in an hour, 155 million requests per day. And if there is like 10 different feature toggles are being called in one single page request, it's possible that those 155 million requests in a day are getting somewhere around 300 milliseconds or 400 milliseconds of time spent just on the call with Unleash. The rest of the processing is separate. So it's possible that the page load time for those 1% user is huge, and we have to do something to reduce these numbers. So what we did is, first thing that we did is we analyzed our infrastructure. In our infrastructure, we have some monolith VMs that we're calling Kubernetes pods where Unleash Edge was developed. Now, there was an Nginx Ingress gateway which was exposed traffic actually goes to Unleashed Edge. This increased a lot of network hops. Now, one basic thing that we can do is just to reduce the number of hops. So we did one temporary solution, although it was not recommended at a lot of places, but we leveraged Kubernetes queue proxy and exposed everything over a node port URL. And we skipped the Nginx ingress gateway and Istio gateway and directly called the Istio sidecar using a node port and accessed the Unleashed Edge service. Now this definitely increased the load on the queue proxy, but our Kubernetes cluster was big enough to handle the load, and our Unleashed Edge service was scaled up enough to handle the entire request base, and we were able to sustain these many requests without these two network hops. So this gave us a good boost to our performance, response time, and we were able to reduce the latency numbers by 30 to 40%. So our P95 came under 14 milliseconds, our P99 came under 20 milliseconds, and our 99.9 was around 28 milliseconds. So was that enough for us? Well, no. See, we are engineers. We always think, okay, let's optimize more. There can be something that we can do even further. So we looked up further, and we came to know that Unleash SDK that we were using also has a feature for caching all the feature toggles on the application server itself. But one of the problems with that is that the cache that Unleash SDK provides, it also contains metric data. So metric data is nothing but how many times a feature toggle is exposed, how many times a feature toggle is accessed. That is the metric data, and it keeps all the metric data inside the cache only. And by default, every 30 seconds, it will clear the metric data and ship it to Unleash main server. Now, 30 seconds is 30 seconds is not that much of a big number, but if you think about a particular feature toggle, which is somewhere on, let's just say, on the top level of the code and being accessed millions of times in 1 million or millions of times in just a few minutes, like 5 minutes or 6 minutes. At that point of time, if a metric is set for 30 seconds, in those 30 seconds, the number of times it's being accessed is also being recorded in the cache itself, and it will fill up the cache. Now, metric data is not giving us any kind of performance boost. It's just for analysis purpose. So the basic thing is the metric data should be as less as possible, and more cache space should be available for the feature toggle data. So what we did is we reduced the metric clear interval from 30 seconds to just 5 seconds, so that metric will just go away as soon as possible, and keep more feature toggle inside the cache, the local cache itself, and give more space to our feature toggles. So that is what really gave us even more further performance boost. Yeah. So rate limiting, we were using Istio, and rate limiting was not required on the Unleashed Edge side. On Unleashed Edge, we scaled it enough so that it should be able to handle as much traffic as it wants. We rate limited Unleashed main server because it was creating load on PostgreSQL instance. So we rate limited Unleashed main server, but not the Edge instance. And this is our final matrix, where P95 was around 5 milliseconds, P99 was around 8 milliseconds, and 99.9 is around 10 milliseconds. And we maintained these latency numbers with 100,000 requests per second, and that was really great for us. And we served around 6 billion requests in last year. Yeah, please.
What is this latency? What latency?
Okay, so this 5 millisecond P95 latency is like 95% of
This is
between the application server and the Unleash server.
not between the server.
No, between the so This is to reduce the page load time for end user. Now, application server has to do some sort of processing on their own, but we were mainly focused on reducing the unleashed latency so that if a developer has like 10 different features on a single page request, still he should not spend like 40 to 50% of its time on just fetching the feature tokens. So yeah, these are our final latency numbers. We are still optimizing it. We have one more architecture change to reduce these numbers even further, where I'm planning to reduce it even by 50% more. But that is still under it, and let's see if that is successful or not. So I haven't kept that in this particular slide, but yeah, these are the numbers that we are facing right now. And we have created like more than 400 projects in Unleash, where we have like 3,500 plus feature toggles, and 2,200 feature toggles is being used in production, and 50 feature toggles are being added every month. Yeah, that's all. Any further questions? Yeah.
So like now the optimized P99.9 is 10. You said mentioned earlier that some APIs have more than 10 calls to feature toggle service.
Yes. Yes.
So that will be again still 100 ms. Are you planning to do some bulk fetch or something like that so that you can get all the feature?
So this bulk fetch is something that will come on the application side. Now, how the application is written or how the developer has written its code. That is something which will require the entire code base change. So that is not something like one person or one team can do. It's a collective effort that every developer has to do. So it's not so bulk fetch is not something that we can do. But what we are planning so as of now our Unleash Edge is in Kubernetes. What we are planning is to keep Unleash Edge on the VM itself, or run it as a sidecar with all the Kubernetes applications that are deployed. That way there will be no network hop at all, and Unleash Edge can be daisy chained. So one Unleash Edge can call another Unleash Edge to fetch all the feature hours, and it won't create any additional load on our main service as well, and it won't it will be extremely fast. So that is the approach that we are trying right now, and that will even reduce our latencies. Like P99 will go down around like 3-4 times.
Instead of having like in-house, don't you think that launch directly can
Sorry?
Don't you think that launch directly can solve the problem?
So we have not. So initially we used in-house feature flag, and that was a maintenance overhead for us. And we have deprecated it, and we use Unleash now. Yes. So yeah, it's a GP. Envoy proxy. Yeah, for no, we are not using Envoy proxy. We are using Istio only for our as a service. Anything else?
Any challenges or limitations you see on English as you've been using it?
Yeah. Challenges on Unleash front. Okay. One of the major challenge that we saw is can I say mainly on the response time side, everything looks good. It's just one thing that we noticed is, so let's say if you have to analyze some sort of data log, it doesn't have any data log integration. They provide integration with Prometheus, so you can scrape your matrices and dump it in Prometheus, but data log integrations are not there. And updating the client side libraries is a bit hectic, and that's the only thing. The server-side libraries and server-side code, there everything is fine. They provide Docker images that you can easily update. Anything else? Thank you.
Thanks a lot, Gaurav. Our next speaker is also an old friend, Nitesh. I've had the pleasure of collaborating with him in more than one organizations. And again, exchanging notes is a reminder of how far we all have come in more ways than one. Mitesh right now is with Arcesium, and he's going to talk about how do we build MLOps CI/CD pipelines, which is one of the hottest topics these days given the advent of AI altogether. Mitesh, you want to-
What was the name of that? This is the one, right? ये नहीं चला? चला ही। F11 escape. But you cannot share it, right? Stop sharing. What is that?
Yeah, good afternoon everyone. So nice to be here and see all the people on Saturday holiday. They are coming here to attend LSP 53rd event. So I am Mitesh and I work for Arcesium right now. I worked with Yahoo, Twitter, Ola earlier. Hello, am I audible? So today I am going to present on simple yet scalable MLOps CI/CD. So generally in this era we are seeing AI and ML are taking center stage, and people are shifting their focus on like getting more out of data what they have accumulated over years. So they want to know insights and get the what we can generate intelligence out of it. So that is ML all about, and let us see how I can help organization to like change from monolithic ML services to distributed and like scalable microservice based ML model serving using services, and they can deploy in a scalable manner so that if more requests comes, their model can serve more number of requests because it requires a huge amount of memory and CPU. So that is the main agenda of this topic. So if you have any question in between, you can ask. Next. Sweet. View full screen. कंट्रोल ये बटन
स्लाइड्स पे जाके करना पड़ेगा.
It is that here. ठीक है. Better. So what is today's today's agenda is what is MLOps, like why we are using MLOps, because generally in traditional way we have seen it is getting deployed by the data science team coordinating with ops or infra, and like how MLOps solves certain issues which will help a company to reduce their time to production and reduce the cost of deployment, as well as because time is saved is time and money saved both, and resource requirement becomes lesser, and then we'll see how we can use CI/CD to deploy ML models, because we have seen generally models go out of sync of the code because code is separate and data is separate. So we'll see how we can solve that problem. Then we'll see how we can actually test the model before actually it is going to a production. Say our current model is in production traffic giving 70% accuracy, and if we do not test it and go to the production, and it may give lesser percentage of accuracy, then it will be bad for our business. And the last one is like you can even deploy multiple models. Okay. Yeah. So what is machine learning model? So it is a mathematical representation. It is a like mathematical formula which actually for the given input it suggests some. So it takes input from one dimension to another dimension. So that is like a mathematical representation along with like the data, input data for training and certain data for testing. So we generally split in 80-20, 80% of data for training, and same data set.
Hold it a little up closer.
Yeah, same 20% from same input data set. We separate out 20% and use it for testing. So, and along with some algorithms, so it identifies the patterns. So if say some pattern is there in input, so are we able to find some output pattern? For example, say we have like if a customer is buying a lot of say kid products, so we can assume that he is either married or having kids. Correct? So this is another example is like so if we train our model on say images of cats and dogs, various, so given the random picture of cat or dog, model can recognize. So similarly, so what we are even searching in Google that is linked to the Amazon can show the ads related to it. So it can predict and then provides insight. So we can see like machine learning model, a problem statement is given, then related to that data collection happens. Then people do data processing, and we can create algorithm on that data. So data processing requires like cleaning of data and deduplication, all those things. And we can tune parameters like certain weightages are given to certain parameters because there are many attributes from this data. So for simpler terms, like we can take say certain employees experience, they are getting this much salary. So if there two columns are there, we can assign some weight to like their experience. So depending on that, we can compute what is the expected salary. See, we have up to say 36 years of age of data. So can we assume compute the value of 37th year, what will be the salary of a person if he is in 37th year? So that example, so we can map that here in this whole flow. Any question till now?
Oh, one thing.
Yes.
Trading is something ML does itself, right?
ML does itself means,
Training in the sense, you train a model, right?
yeah.
You give a data and ML learns this algorithm trying to make sense of it. Am I right?
There are two ways of learning. There is supervised learning and unsupervised.
Learning, right?
Yeah.
Okay, that's
So
right.
in supervised learning, we have to we have to label the data. Means if this is the input, what expected output it should be
Okay.
giving. Yeah. So why we are using MLOps? Because it provides efficiency. Because say if a human is doing, he will take time to do that same thing in say 2-3 hours. With say if we are doing in automated manner, that will decrease and increase the efficiency and decrease the time. Second one is scalability. We have in bigger companies we have multiple set of inputs and separate models can be created. So all those things can be taken care in parallel multiple pipelines. So that is the scalability. And third one is reliability. Since CI/CD is generally immutable, means given the same input, it provides the same output in an idempotent manner. So that improves the reliability, because if I am sure that say this person that git commit has gone in the say stage and it is working fine. If I put the same code in production, it will work in the same manner. That is the reliability. Then collaboration. If a person is doing same thing in laptop, if a person goes out of company, then it is hard to say some other person in the team to simulate the same thing and produce the same model again. So it takes care of that collaboration part also. And it helps in compliance. Compliance in the manner we can show to the audit people that this is how it is going and who all are can access this models. All those compliance related and security things can be taken care, because it is not going out of company, means not from the personal laptop. And fourth one is risk reduction. Same argument goes for compliance and reduction. Risk reduction. So what is MLOps? So it is generally DevOps for machine learning. So we can extend DevOps to the machine learning. It will help people who are in DevOps. They can think that they can increase their horizon to another area. So they can future proof themselves, so that their skill set won't become redundant. So in that manner, earlier DevOps was like this. We can add one more skill set in our arsenal. So that is what DevOps is. So it helps in linking the data science people to the operations, how their model is going to the production. So that will help in reducing the cognizance load on data scientists. So they can even see how their model is behaving in production. So that is the advantage. And it streamlines and standardizes the model development and deployment and maintenance. Any question till now? Okay. So we have seen features of MLOps. Now we can see certain issues when I was trying to deploy some. I was communicating with data science people, and they want first time I was trying to deploy their model. So they know about how to build a model. but like they did not have any mechanism to take it to the production. So what I did at that time, I have just created one. It was written in Python, so I have just used Flask API, wrap it, and then I created service over it and deployed. And they were happy, like they were able to see actually their model going in production, and they can other teams, other developer or services can use their model. So it helped a lot by reducing the time and save a lot of time and energy. So currently, generally people do version control in Git, but they are not able to reproduce the model because input data can change. So there is no way of linking. So we'll solve this problem in today's session, so that I know my code and data are same and it will always do the same model. And third one is the deployment part, so that we can deploy in efficient manner and is scalable. So this is the way we are solving these 4 problems we are solving. Any question? So I hope who are attending this LSP, this CI/CD I have shown for like code microservice deployment. The same microservice deployment can be used for machine learning. But I have given earlier, like we have developed a mechanism where in Jenkins we have created plugins in client-side manner instead of server-side. So we have developed certain plugin to manage the Git version and the model version. So integrate those. If those two are integrated, then this pipeline can be used in the same manner, just like microservice. We built microservice over model science, machine learning. So any question related to this? It is like it scans the code and model, machine learning model is built and it is integrated in Docker container, and that container is deployed by exposing the endpoints, say slash model predict and some JSON parameters, and it gives the result in JSON.
What are your tests? What are your tests?
In API testing?
No, checking before promoting the products. I mean, let's assume API test everything working fine. And now, what are the criteria you are following to promote the products?
Say, so some tests are like initially only like model, the developer of that model knows. That testing is done here itself, so container is not. Say if it is deployed in stage, say only initially 0% traffic goes to it. So then they can data their endpoint because it is separate endpoint. So it is not serving any traffic. So they can test if initial say testing of endpoint is up, and say if I know some prediction because I have tested locally, so I know if I give this input this should be out. If that is passing, then say I increase the 5% traffic here, and if now people are not seeing any failure, then I will increase to 10%, then 20. If everything goes fine, it is promoted to otherwise.
The traffic is routing and that is the real traffic, or it is a mirror of
In a stage it is generally synthetic, means whatever developer can generate, but in production means other services can generate, but in production real traffic. So as I told in the previous slide, if I show, so it has lot of stages. So to simplify the things for understanding, I am creating another explanation how actually model is built and how it is related to code. So if you can see here, developer commits his code codes here, but he also can generate model on his laptop. So that is sent to S3 bucket or any large data, because if we are sending say a model is bigger than some GB, it is not good advisable to pass in.
So when you say a model is sent to S3 bucket, in the end models are just binary files or like.
Yeah, it's like for Python comes pickle file.
Okay, got it.
So only code goes from this line and model goes to S3 bucket. And say he forgets, even he forgets that is not a problem. And build model, if it checks, if it can pull that model combined with that commit version. If it is not in S3, it will use. Otherwise, it will pull directly. So it will save time. So in that manner, our Git repo limit won't breach. And that is 300, 400 MB. And our model is greater than 1 GB. It is not advisable because it will take a toll on hard disk of like Jenkins pipeline. So because it has to copy the same artifact on every machine wherever the stages are. So that is so once model is pulled, it is built the container, it is pushed to ECI, Docker repository, and on production, that since model is there in container, it is pulled. Once it is pulled, it will be always there. If even if it restarts, one advantage. But problem is that our container image becomes large. But I am showing this is the first version. Like whichever feels you feel good, you can use. So I am showing both versions. Yeah. So I was talking about earlier that version control and model reproducibility. Like I want to link my code with my model because my code is tightly coupled with the data actually on which training is happening. So generally we find that this mismatch happens sometimes and our model can serve wrong things. We don't know. Say I have created code for like this data set for training, and our model if I do at runtime, next different kind of data can come. Then problem may happen that we see something else, even failures. So we need to relate the two things like data and code and model. These three things should be like linked to a version number. So Git doesn't provide with LFS, but it is not everywhere available. And also I have told the disadvantage of having bigger model files inside repo. And if you are hosting your Git outside, then your model get exposed outside. So those four things should be avoided for best practices. So how we can relate like our Git code to actually data? So there is a tool developed like by data version control and it's like lighter version is DUT. So those two can be used. So any confusion or any clarification needed for this is
Will you be giving a demo of how the version control works?
yeah. So this slide. So for example, if your code is there, you write your code and you write when you run your model in local machine, it generates a pickle file, for example. So that pickle file will we put in .thing. Instead we put in .dvc configuration. Okay, that my code is generating this pickle file. So you store it. So first we do dvc commit. So now it remembers its own commit ID. And once we do git commit, it is linked to that git commit ID. So both two are now linked. So I am sure, and DVC is sure that this code and this actual data file and model. So training data. So we can link the training data also. And then we push to git server. So only code and system code. So if you push git push, then our code only goes there because we have put all this pickle file and data files in git. And when we do DVC push, it will push to S3 configure wherever we are. So now our model is pushed to S3, and see this model. So you can see this is just a link to this actual pickup. So it is pushed to S3. So your bigger file is not going to Git. So your Git looks much better, and whosoever like Git clone or whatever your team member does, right, they will be a very small, faster, and whichever model is required, this will save the time. So you can use this. But this is little like heavy, and means like 200, 300 MB size. So you can use that also, whichever you use. Yes.
What happens in case of pre-trained models? So in that case, if I use an existing pre-trained model, do I get the data and the code goes?
Then you can like pre-trained model you can push in S3, and while building you can pull from S3 directly. No problem. While building you can pull from S3 because in pipeline your laptop is not accessible. So pre-trained model can be put in S3, and while building you can do AWS S3 CP, pull that model and build a more bigger model, or multiple models can be put. Did I answer your question? Yeah. So this is another way, like as I told you, there are two ways you can do. If we say if you don't want to integrate your model in Docker, it will be quite fine. You can run your content at init stage. Simple. So your container image will be small, but the advantage of Docker cache will go away. So whenever your service container dies, it comes up, it will be slower in this case. Any question related to this? So how API testing can be done? I have created a small flowchart. Earlier I tested with AWS load balancer and DNS traffic weighted mod by changing the weights. But it was slower. In Kubernetes they provide via Istio. When I tested it was with ECS. Now this works with EKS. So I am explaining EKS wala workflow so that most of the people who are using EKS with Istio, Kubernetes with Istio, use this for API testing of model or any microservice. Here this server is running. So here the server is running, which can like changes the weight for the service deployment in blueprint. Okay, so it starts and wait for like client to come, and when client starts, it sends that I started running. So now server knows that it has started, so it's waiting for like percentage increase. If somebody has configured Istio or blueprint deployment, they have configured destination rule inside virtual service. So you can have multiple entries there. So if weight is changed, the client has changed the weight. So initially I told 0% is traffic is going to green. We have seen like green here, then blue. 0% traffic going to green. And if weight is changed, now 5% traffic is sent to the now green. So that you can test like if my service is working fine and able to handle little load. Means it is giving correct output for 5 axis. All those parameters once those are analyzed, it will do API testing related to it, and if it finds that it is failing, then it can roll back the weight so that zero traffic. Otherwise, it will say increase again till say 20%.
It's like a A/B testing.
Yeah.
Okay.
Adaptable. I mean, it is completely run by developers. developer.
Humans.
No DevOps running picture, so life of DevOps becomes easier. And I have said like limit of 20%, so not more than 20% traffic can go back. Even if new model is not working well or some error is there, still 80% of customers will see right. So we can set boundaries depending on the organization. So any doubt in this? So, like in coherence with previous slide, just how Blueprint deployment works. Most of the people know that if blue is coming from client, they can go. In Canary, automatically send to data. Any question?
So, ML ops is notorious for being very difficult.
Yeah.
Very difficult, very complicated. The way you have explained is very simplified. Have you toned it down, or is it that you have managed to simplify it? Because from whoever I hear about ML ops, they say it's a pain in the ass. Seriously, everyone. I mean, there are memes about it. There's ML ops
Yeah.
stuff. Tell us more about it.
So, luckily I got chance to work at CRED from the start as a founding engineer. So when ML ops was in nascent state, means it was starting, I told the story that data science engineer approached me to deploy in production. Then I have given him wrapper because we had, when we started with microservice approach. So luckily he came to me and I suggested, I saw how it works and I have created wrapper API over it, and he liked it, and other developers also liked it because they can now hit their URL from any of their service. So it becomes easier for us to mold that in our microservice based deployment. So we mold that problem into microservice problem.
You have already simplified it a lot. Tell me the complicated things.
Linking the data with version of the model.
Okay.
That was the hard.
Where the complication is?
Yeah.
Okay.
Because it goes out of sync, you never know where. So we wanted to link. So then I saw this tool DVC, but it made our pipeline little bloated because of size at 100 MB, and it is little slower.
And I'm assuming the 500 MB is a very small example. In real world, it's supposed to be in GBs, tens and hundreds of GBs.
Only I'm just saying DVC itself is a little bigger, but it solves many other problems also.
Okay.
Then I come up with that. I have used on my laptop as a POC, but not yet taken into production. But I have taken using DVC. So it helped a lot, like to link code to the model. It solves a lot of problem. No uncertainty that if I am deploying this code, this is the model running, and if I roll back, it is not working well. Roll back to previous version, it will serve the previous kind of. So that is the biggest problem.
So like Git has both pre-committed, post-committed, but DVC has those.
Yes.
So run scripts as per the operation being handled.
Means DVC I used only the relation linking the Git commit to the data and model part.
Okay.
Not more than that. It has a lot of other features which we don't need. That's why I told it is little bloated.
There is no other way binding, like git commit also no.
We can do one thing is that we can do from our side is that like when we do git commit, but say if we are building model, it is generated before, like the developer is sure about committing. So future commit ID we don't know. Correct. So that is the problem. Otherwise we can do one thing, we can commit, then we link the model by naming some convention we can take and put in S3 that my commit ID is this, I can pull this model. But it is like still a loose coupling is there, and it's I'm not sure whether somebody has linked correctly. Say developer can forget and to link it back. Then if that model is not available, so we want to avoid all those corner cases. So DVC fit the like that. Any other questions?
All this applicable for GenAI, LLM models, or is there any difference? Is both same?
Any model means you if you can run anything inside a container, everything is possible.
How to handle continuous integration? Like
Yeah.
you have shown one picture in which PR is generated and whole chain you have shown. That is for one engineer.
Yeah, it is CI plus CD.
Suppose multiple people are working on the same model with their own code. So the already running chain will get
So yeah, multiple people are working on like generally they work on different branches. If even if they are working on different, so that is why the help of that Git and model linking, that will be saving from that collision of multiple people working on same. Because commit IJ is different. Even data remains same, not a problem. If commit IJ is same, data doesn't change, then it will link same data, not a problem.
So DBC will also have that branching? DBC is handling model like data, right?
Yeah.
Different branching of
Branching, yeah.
Git branches and does the DBC also have separate
Yes.
separate branches?
Yes, you can switch when you change the branch. It will change. Yeah.
Is there any single tool for this whole ML? Like we have
Single.
software, like we have Jenkins
Ah.
for whatever. Is there any single
Uh,
tool which covers?
So this slide which I showed earlier, this one is most of the things are running on Jenkins, but yeah, deployment happens on Kubernetes or ECS.
Is Jenkins?
I did on Jenkins. Any other question? So you can provide your feedback by scanning the code.
Definitely, sir. Thank you.
Yeah, you take the picture before it goes out. Thank you so much for attending. Any other question you can ask me around, or you can send me on my mail or. Thanks.
Thanks a lot, Mitesh. Folks, we will quickly break for lunch right now. Please help yourself. And we will reconvene for the other talks post lunch, close to 2 o'clock. The good thing is, close to 2 o'clock, the good thing is that we have already made up for the time that we lost. Actually, so that's really great. And yeah, we had some construction noises, that usually ends up happening. So, yep, thanks for putting through that. Cool, guys, enjoy your lunch.
Good afternoon, everyone. Hope you had a great lunch. Now is it loud enough?
Yeah.
So the topic of this talk is behind the edge, where we talk about LinkedIn's journey towards how we build a resilient multi-edge architecture. So I talk about edges because that's like a keyword here. So yeah, before I start, a little about me. I work as a senior SI with the LinkedIn's edge infrastructure team. So what that means is that when you make a request to access LinkedIn or LinkedIn.com, we are the ones that make sure that your request reaches LinkedIn's data center reliably and fastly. So that pertains to handling LinkedIn's edge infrastructure, which involves handling our public DNS. Like the DNS will tell you which IP to connect to, which server to connect to. That also involves handling our edge proxy process, or in general terms, they are called CDNs. And by edge proxy, when I refer to edge proxy in this talk, I would mostly mean the proxies that handle dynamic traffic, not the cached traffic like images, videos, and all that JavaScript. So we also handle edge proxies for reason. These are the ones that accelerate traffic to our data centers when users connect to it. I'll talk more about that later on. We also handle the certificate deployment and all the things that involve provisioning them, because when you connect to an edge proxy, it will give you certificate. We also handle our content delivery networks, like providers like Akamai and all, which serve things like JavaScript, LinkedIn is up for the users all the time. So the scale that we operate on is currently like 2 million requests per second. That's just dynamic traffic. If you add other CDN content, cache traffic, that will be like even much higher. So moving on to the agenda of the talk. So we have 5 things here. First is like I'll go over the background to tell people what Edge exactly means or how it works. Then we'll talk about our journey to how we reached the current state of our Edge infrastructure and what wins we got through that process of transformation. Also the learnings that we got through this process. And we'll keep the questions at the end in the interest of time so that we don't steer off the actual discussion. So yeah, starting off with the background. So for that, let's go back a few years, like up till early 2020. LinkedIn used to operate its own edge points of presence network. So we had like tiny data centers all across the globe, around 90 data centers. So when a user wanted to connect to LinkedIn, first it will connect to one of these tiny data centers that we used to manage ourselves. And then the request will be fast forwarded to the data center through our LinkedIn app. So the SSL termination used to happen here. This was in SSL proxy. But there were problems with this thing. It was very hard to manage. We had to manage POP upgrades, maintenance, outages, and it was also really hard to grow. Like when you need to set up a new POP, you need to provision a lot of things. Like you have to get data centers and all that stuff. And it was also really expensive as you grow this thing. So what we decided, like there was a huge effort to migrate to Azure. So what we did was we entered like our AFD era that we call it. So LinkedIn started using Azure Front Door, which is owned by Microsoft, or AFD, as its edge network. So AFD is a platform that provides its own edge POP locations all over the globe. There are like 192 edge locations. And when you integrate it into your stack, the request for the user will be first intercepted by AFD. Our DNS will tell, okay, go to AFD. And then, because we have configured it in such a way that AFD will take the request through Microsoft's own backbone, and then the request will directly jump into LinkedIn's backbone. This is really fast. This is the slower part, but because AFD has a lot of POPs all across the globe, that makes that last mile really fast. And that's how we ensure that the users have fast experience when they try to access www.linkedin.com on their browser and get our email page returned. For this, we are just talking about dynamic traffic again, not the CDN assets. Those are fetched using different CDN providers. We also had a secondary fallback path. Another fallback path is that we let users directly connect to data centers in case there's some regional outage, some country level outage. We have monitoring setup, alerting setup, and automation also setup on top of that. So whenever there's an outage, we change our DNS entries through that automation and fail back traffic to data centers in certain countries. So that way, we are still available, but we are slow. So it's better to be available than it's better to be slow than be not available. Right? So we are still serving you that using that. But let's say you're in India and your request has to go all the way to America. That takes a lot of time compared to just connecting to a POP in India and then taking the back. So this used to work, but again, we identified a few issues with this thing. So the problems were that AFD was the single point of failure at the edge. Although we do fail back to our data centers, and the outages were minor outages are there, like internet is a crazy place. There are performance issues and all that keep happening, and our automation was taking care of that. But when there are like major outages, we are forced to serve a lot of traffic to data centers, and that led to degraded performance for our users. Another major challenge that we were facing was we were getting DDoS abuse on LinkedIn. So around May or like around early 2022, during this Russia-Ukraine war, this anonymous Sudan group was targeting a lot of big American corporations, and because LinkedIn is part of Microsoft, it was also targeted. did get hit pretty good. And Azure's WAF was still in really early stages that we were using, and we had recently onboarded. We were still using it in terms of threshold and all that. But still, that wasn't enough. It was pretty basic. And it's not a very advanced piece of software yet. It was still in early stages. So we thought, okay, how can we solve this problem and add more resiliency to our stack?
One question over here, AFD is a proper full-fledged DC, right? Azure DC, right?
Multiple data centers of
But
Azure.
it's a proper DC, AFD.
It could be smaller DC as well, not a proper DC. They also use other DC. So we thought to ourselves, why should we just rely on Azure? So although it's a Microsoft company and Azure and all seems to be default, but we shouldn't rely on Azure because that makes a big dependency on that. So we thought, okay, who could be better than one, right? So we did a brief study of different edge providers that are available in the market. One of them is biggest one is Akamai, but that's very good for cached content delivery. They also lease ISPs, data centers, and all to serve the traffic. But it's not that suitable for our use case where you have to serve dynamic requests. We stumbled upon Cloudflare, which is known to be very good for DDoS protection, and they also claim to have edge presence. So that's how Cloudflare entered the scene. So because we are going through all these problems, we went to our team, to our leadership and all, and we made a proposal. So in theory, if we add Cloudflare as a secondary provider to our stack, it could solve our problems. So AFD was a single point of failure at the edge. So Cloudflare can add that redundancy, and we won't have to rely just on AFD during outages. There was DDoS abuse going on LinkedIn, and Cloudflare claims that they have the best-in-class DDoS protection web application firewall. So let's just try that out. So we made this proposal. The infra could look something like that. So, and we went there. So people were happy. They were like, okay, we are looking beyond Azure after a long time, and they were quite excited. So thus we started our evaluation, because we had to serve actual traffic using this stack. So we had to be sure that it meets our needs, that it does not degrade performance, it does not degrade the site availability. Also, because we wanted better DDoS protection, they should have what they claim to have. And also it supports the protocols and all that we need, like HTTP2 or some other TLS version or some other functionality, like we have some rules set up on AFD, that should also be possible to set up on outside. Plus some other things that we offer that is also better. So we started our evaluation on that note, and then we came to our first phase of evaluation, which was just probing hosting objects. You cannot just serve actual traffic through it initially, so you have to just host an object on your server, try to make that request via Cloudflare or AFD directly to a data center and see how that performs. So this was just to gauge availability or like gauge the metrics initially without going full-fledged into this thing. So the metrics that we decided on were availability, round trip time, and throughput. Like we'll measure on that. We cannot actually test DDoS protection in this phase because it's just hosted objects, like some 43-byte object or 100 KB object hosted in our server, and we poll it to just get the speed from a lot of different nodes across the globe. For that, we had two strategies. One was collecting real user metrics. For that, we used it's a third-party provider called Selexis. Now it got acquired by Citrix. It's called Citrix Intelligent Traffic Manager. So what it does is basically it can collect real user metrics using a JavaScript that you embed in your page or your app. So when a user opens your page or app, beacons will fire to different platforms or different beacons. AFD will go, Cloudflare will go, your data center, some other provider that's happening. And it will report those numbers to Selexis if it was aggregation. It also does some de-risking for you, but we were not concerned with that part here. We were more interested in those metrics. The other thing was, like, obviously you will do for that, we use something called Catchpoint. They also have lots of nodes across the globe. Although it won't match LinkedIn's user demographic because these are from actual LinkedIn users. These are from Catchpoint's nodes. So, and they have nodes across the globe with different ISPs. They offer very good insights into different kind of metrics like time to first, SSL time, connect time, or like total time to. So we use these two methods, synthetic and real time, for measuring performance of Cloudflare against Azure Front Door and our data centers. And we had some findings. So the good thing that we found was Cloudflare was doing very well in terms of throughput. Throughput means like the time when the connection is established from that time till the whole object is loaded by the page. So it does not include the time for time to first. It includes the time when the connection gets established. Its overall availability was also marginally better than AFC globally. But there were some bad things. That was the first challenge that we got, that it had higher TCP connect time and SSL time. Like there was some constant delay that was there. And it had much higher round trip time in Southeast Asia. Round trip time is like when you make a request and you get the first byte of
So
response.
basically the latency was high.
Yeah, round trip time, like response time, just the first byte. Overall round trip time for Cloudflare globally was also slightly higher than India. So these were some challenges. We thought, okay, we should go ahead and try to get it fixed or work with their team because obviously it's not our stack. And what are the issues we have to try to recognize those. So for TCP connect time, we figured that it could be because we lack peering. So there is no PNI like peer connect thing that with Cloudflare we had it with AMD. So when a request goes from Azure's POP to LinkedIn's data center, first it is in Azure's ASN. Now it has to make the next jump to another ASN to reach LinkedIn's ASN. But if you get the BGP peered in one of the network exchanges, the next hop will directly be in our back. But that was not at that time. So we attributed that to lack of the PNI. Also the connection reuse between Cloudflare's POPs and LinkedIn's data centers was pretty low because so when you use an edge provider, there is a lot of connection reuse between edge POPs and your data centers. So there aren't a lot of connections open with the data center. But there were less connection reuse for Cloudflare because we weren't sending a lot of requests. Another thing, second issue was higher round trip time in Southeast Asia. We had to work with Cloudflare's WAN team, the network team, we got into several calls with them, and then they figured out that there was some issue with the link, like some link routing. So they changed some configuration on their network side, and that helped improve the round trip time, although not better, but still it was within the acceptable range, around 10%. So for overall round trip time, because all the Cloudflare's overall round trip time was higher, what we saw that although throughput is like much higher than AMD, which is better, so that means like the total time to load the object, if you take round trip time plus the time to fetch the object together, that comes into very acceptable range or even better range. Because so you have to choose the correct metric. If you take the two things together, it represents the actual page load better than actually taking it separately. Like just taking round trip time or just the throughput will give you a better picture. So that was the first thing issue we came up with. We again went back to other stakeholders, team leadership and all to go ahead and move on to next stages, which was doing A/B testing with production traffic. So this was the stage where we want to send actual LinkedIn traffic through Cloudflare, although not like it's not a full contract with them, but still you have to at least test if it works correctly. So we got a mini contract with Cloudflare just to do this evaluation for that. But then we stumbled upon our next challenge, which was that
LinkedIn also has its own inbound L7 process. So when a request lands on its data centers, it has to have some interface, right? That is ATS, Apache Traffic Server. That's another L7 proxy. So our Apache Traffic Server wasn't ready completely to work with Cloudflare. It wasn't integrated well. It was done during AFD migration, but not with Cloudflare. So first issue was that many requests were getting rate limited because Cloudflare thought, because ATS thought that requests were coming from one single IP. Then there was no connection persistence as well. We approved access timeouts. There was no network peering again, and we also didn't have any integration with metrics or logs to at least get tracings. Like we were not logging Cloudflare's ref ID or any other things like what's the actual version of the request. Also, we assign a data center to each user, like per week, and we use a lot of things like round-trip time between different data centers of AFD and our data center and other things like capacity of data center to be able to serve each user better. But we didn't have that integration with Cloudflare, so that was another thing that we had to change in our stack. So yeah, so we went ahead with it because Cloudflare, because ATS thought a lot of requests were coming from single IP, so Cloudflare's IP, it was blocking them. So when a Cloudflare forward a request to your origin, it will add a header called pro client. You have to make changes to your servers to be able to actually get the actual client IP and use that. We also tweaked our TCP connection timeout settings on our servers to be able to have that connection pooling for a longer period. We also got PNI link set up. We worked with our network teams with LinkedIn, and again we made changes to our algorithms and whatever jobs we had to assign a particular DC to a user using Cloudflare dependencies as well. It's more involved logic, but yeah, we had to make that change as well. So yeah, we were done with that. So we came up with a plan. First thing was, okay, we'll test the functional correctness. Like, when you serve traffic through Cloudflare, does the site actually work as intended? So first, the easiest way is to, okay, you will send employees traffic. You will make changes to your internal DNS and point all the users to Cloudflare for your company. So that was like preliminary testing, and we were able to go ahead with it. But we don't test all the paths in the code or the website when you do that. So we picked a small country, which was Bangladesh in our case, because we were in India and similar time zone. So then we ran traffic in Bangladesh. We evaluated if there are any issues coming in from different front-end teams, and if everything is working fine. And thus we verified, okay, functional correctness is there. We moved on to performance testing, like evaluating things like page load time, availability, all the other things. So again, because you're serving so much traffic for your website, and if there's any issue even in performance, you could lead to revenue plan. So we had to do it really slow. We targeted a few geographies, some mid-sized countries first, then we went to some larger countries and then sent traffic slowly through Cloudflare. And we did all that split using DNS itself. Randomly send, let's say, 90% through AFD at a time, 10% to Cloudflare. That split was done using DNS. And yeah, when we were sure that, okay, you can serve certain geographies correctly, then only we started ramping actual lower traffic, and we left it for like 10 days. We served, so at a point we were like 80% AFD, 20% goes to Cloudflare, and we left it like 10 days to collect data. So last part of the plan was, okay, you also want to test DDoS protection. It's actual production traffic, and that's possible, right? So we turned on the web application firewall. Although we had some rules in blocking mode, like threshold rules, rate limiting rules that we already had on AFD, we just copied them. But there were certain new things that this new WAF for some automatic DDoS protection, some bot detection and all. And we didn't want to actually just block the traces all the logs and everything, and see like what works for us, what does not. Yeah, and this diagram just shows how we split the traffic and then collect metrics using our internal real user monitoring instrumentation. So yeah, once we did all of that, we came up with a big report summarizing the performance. So for performance, what we found, our metrics for evaluation were base load time, because that captures the whole thing, and availability. So globally, we found Cloudflare was either better or marginally better than AFD, so that was good for us. In Europe, South America, and Africa, Cloudflare was doing better than AFD. So there were like different measures, right, for any metric. There's average, P50, P90, P95, and all. So overall, what we found was it was better. Now, for North America, Asia, and Oceania, AFD was better than Cloudflare, or slightly better than Cloudflare. Especially in North America, it was pretty competitive. Asia, Cloudflare tended to be slower. So just to elaborate or illustrate, for Africa, if you see, Cloudflare has locations in a lot of places, and these green ones are AFD. Cloudflare even has box in Madagascar or something like that. So that tends to give better results to us. So some observations are that Cloudflare was doing very well for tail latency. P90, P95 tends to be better than that. Maybe because they have so much presence, that tends to get us better. So this opens up ways for LinkedIn itself to serve users who have slower internet connection, or geographies which have poor internet infrastructure, especially like Africa, or maybe some parts of India. Cloudflare also showed positive performance in Europe. They tend to have lots of WAP in Europe as well. In America as well, it was pretty acceptable. So we went ahead with it. And another thing was it was lower initial effect, as I mentioned earlier. But it was still good, better than serving the data center. So it can still serve as a secondary provider. So these were the performance numbers. You can just have a quick look at the graphs for it. So it's like dark green is minus 10%, means like payload time went down by minus 10. Yellow will be went up by 10%. So if you see for P90 and P95, the graphs are green. It shows that it tends to decrease base load time by a lot. Or for data. For P50, it's still a little yellow. It's like 5%, 3% higher in certain regions. That is still unacceptable, but it can be a secondary provider. So when you combine all of that, the average will reflect like not exactly an average user, but still it combines to come something new. So we have to look at a lot of numbers for that, and it looked good for us, at least for the use case that we had. Another thing we were evaluating was feature set. Obviously, like first feature set was having a good DDoS protection and WAF. We saw during our evaluation, we saw minor blocking by certain WAF rules. So we had to tune certain rules correctly so that it works better in the future. What we saw from their dashboard was that they offer a better DDoS detection, and also their analytics are like fantastic. We don't get that much information for AOD's licenses. And during the course of 10 days, it was able to block around 2.9 billion requests just with their automatic DDoS protection. We just turned it on. There was no rules that we had to set up. Another miscellaneous things were that Cloudflare has support gRPC and end-to-end HTTP2 and all. Every didn't have it back then, so we were also able to test that. Our teams internally really wanted to have a taste of gRPC, and they had some use cases for it. So we went ahead, we showed all of that to our leadership, to our stakeholders and all, because now you are happy with any provider, you want to get a contract with them, you want to go ahead. So we did the initiation, and then when we were done with all of that, we started our integration phase. which was the production rollout. And yeah, so for production rollout, what we decided was our steering logic will look something like this. For Europe, South America, and Africa, we'll serve Cloudflare as the primary provider, and AFD will be secondary one. Last fallback is you use linked data center. For North America, Asia, and Oceania, AFD will be the primary provider. Cloudflare will be secondary, and linked data center will be final provider. So this was done because we had the numbers, we had all the metrics we wanted, and it reflected it well. Also another thing was that we wanted to keep the backend connections warm, like between each POP and the data center. So let's say in case we have some failover, the requests are slowish. So we decided, okay, we'll serve like 5% of the requests with the secondary provider. So let's consider if Cloudflare is being serving as the primary provider. Now in normal case, we'll serve just 95% with Cloudflare, rest 5% will serve with AFD. Similarly in this case, AFD is 95, 5% Cloudflare. So in case AFD goes down, you turn it off, but all of it goes to Cloudflare. So it's just a split to make sure that we have backend connections warm, and users when we switch some provider off, they don't get slower connections in the beginning. But again, we came up with another challenge. Our auto failout setup wasn't meant for this complex logic that it's 95.5 as primary, then you have to fail out, you have to turn something off and on. So it wasn't meant for this kind of multiple provider logic. So again, we had to work around our DNS failover chains somehow. We added new CNAMEs in the mix to get it to work somehow. And it's still it works for now, but we are still evolving the platform now. And hence we started the ramp. This is a screenshot from the middle of one of the ramps. So it's like per minute requests are somewhere around 60 million or over 60 million per minute. So that makes it 1 million per second. At that point, our was serving 40% of the global traffic. Right now, it's 40% of the global traffic. This is from the middle of the ramp. And we were ramping our traffic. Then we came to another challenge. So, as I mentioned, Cloudflare had automatic DDoS protection, but that started blocking our legitimate traffic, and it caused multiple incidents. In fact, multiple different teams came to us that they are having product metric degradations. They are seeing drops in their user sessions now, and that was really concerning. We got multiple incidents internally. We had to turn those features off initially, which led to a lot of garbage traffic coming to our data centers. But then we worked with a lot of front-end teams to tune those rules. Even the automatic DDoS protection rules had to be tuned somehow, although initially they told us, okay, we it works, but it doesn't in every case. So a lot of requests were getting tagged as 403s. So when an app crashes, even the 403s that are logs on Cloudflare's back, they were also getting tagged as like some error in the app. So we had to get that fixed as well. And when we fixed it, it's still a continuous process, it's still going on. But when we did it, we went ahead, we reiterated, and we reached the stage that we are on now. Now LinkedIn stage looks something like this. We have, for any user, there are 3 paths to reach LinkedIn. Either you go to Azure front door, then the request takes Microsoft's private network backbone. Either you go to Cloudflare, request takes Cloudflare's private network backbone, or in case you're not connected to any of them, you'll go directly to one of our data centers. So yeah, I would like to point out, so I mentioned LinkedIn has 19 POPs initially. We have decommissioned all those POPs. Now we just have data centers. We use providers or just the data centers.
So, which will be using all 3 parts?
Yeah, these are possible paths, and that is decided, like that logic is determined within our DNS. We have put that logic. So, as I mentioned, in Europe we are serving primarily by Cloudflare. If there's some issue in any country in Europe, we turn Cloudflare off in that region, and then it fails over to three possible paths to reach LinkedIn, we now have redundancy. So what wins we had was LinkedIn was closer to members in 91 more countries. Cloudflare has presence in 91 more countries than EF2. We eliminated the single point of failure that we had at Edge. Yeah, Azure was the one, but now we have two providers. So we at least will be in the state where we don't have to serve directly by data center at all. Like if two providers are down, that's a really rare case. We have better DDoS protection, obviously, like Cloudflare does offer a very good analytics and all that stuff. They are known for that, in fact. We got modern protocol support like HTTP3, TLS 1.3, zero round trip time, session resumption, and all these features aren't there on Azure yet. And our teams were really interested to test it so that user experience gets better. HTTP3 tends to be somewhat faster than HTTP2. And recently we have enabled it on Cloudflare. And all of this led to 25% reduction in cost to serve. So because unit cost for Cloudflare is lower and we have distributed the traffic between two providers, the cost to serve came down by 25%. It didn't increase, like adding a new provider didn't increase the cost. So these were what the wins that what we gained. And there were some learnings. So one learning was, so when we were evaluating, we had so many providers, so many metrics that we ourselves got confused what to evaluate on. So we decided, okay, we should keep it simple. Like choose the metrics that matter to you most, which actually reflect the user's experience. So page load time was the metric that we decided on. We had lots of metrics, time to first byte, SSL time. That was just making it difficult for us to make a decision as to is it good or not. What we learned ourselves is that our stack needs so many improvements that adding a new provider needs a lot of changes. So we have to streamline that process. We are still in the process of that. We have at least documented it in a way that it becomes standardized, but we are still in the process. WAF tuning of the firewall is a very continuous process. I don't think it's going to stagnate anytime soon. Traffic patterns change, internet trends change, any new kind of attack can come in. So that's a continuous process. And two is better than one, like what we thought, at least in the case of edge providers. It's better to have two providers to serve, and it just makes things better. And we are done. If anyone has questions, I'll open it for that. For Cloudflare?
What is your renewal?
6 months. So for Azure front door, they have integration with Azure keyboards, so it just auto renews it and fetches it. For Cloudflare, they don't have any such integration. We will build an automation to do that, but still the process. We do it manually, we have alerting, monitoring, everything set up to make sure that nothing fails. But yeah, these certificates are still manually developed.
There was one page, it was message for security agents. Right? So that is monitoring only the layer cell and DOS. Right?
Yes. So for catch points, they offer a lot of different kind of tests. You can also do trace point, DNS test, SSL test, or ping and all.
These are the layers. Now my question is the entire architecture. How you are monitoring the layer 4? And if any call is happening to the DC, then how you are monitoring that here is the layer 4, the layers there. And third question is that if there is a DC1, DC2 you are communicating, then how communication is monitoring?
Okay, so first question was the layer 7.
Layer 4, how is your monitoring talent?
Metrics like TCP connect time are there for metrics. So we do collect that using this thing. Sedexis does not provide that, but CashPoint does. So we were looking at that as an option. ICMP tests are also possible if you want to do CashPoint. Even trace out. Sorry, what was the other question?
The third question is, if communication is happening between DC1 to DC2, then how you are monitoring that?
So per unit cost went down. You split the traffic across two providers. So on one provider, the traffic reduced, and the other provider offers a cheaper price. So that way, the cost will go down.
Excuse me, I have a very basic question. So, how does the domain resolve it? Like, are there any domain controllers? Like, let's say when we are putting www.linkedin.com from any part of country, how does it resolve? How does routing happen?
So, as I mentioned, our team also manages LinkedIn's authoritative name servers. So, we are the ones that tell that, okay, if someone writes www.linkedin.com, it should resolve to a certain IP or a certain CMAC. So, we are the ones that also do that change or manage that automation.
So, that is like it comes after the Azure framework or it comes before?
It's before. So when you are in your browser, you type www.linkedin.com, there will be a DNS query. It will go to a resolver, right? And then it will do some iterative search. It will go to .com, .com. Then .com servers will tell that, okay, LinkedIn.com is not present with us, but it's authoritative with one of our providers. So it's Azure and another provider is NS1. So we also have two providers for DNS as well. So then the call will come to our name servers that we handle, and we put that entry. And then you will get that answer to your browser. Then your browser will have the IP because you got the DNS, and then you'll connect to whatever server IPs you got. Sorry, you don't know. Sorry, I don't know which one. There is no DNS. Okay, yeah, got it. This thing. Yeah. Yeah, so that's LinkedIn has its own instrumentation to turn on or turn a feature on or off. Feature toggling. Yeah, feature toggling. So on Android devices, we use this. We did DNS steering using this thing. So send some users to LinkedIn, to Cloudflare, some users to AFD. We had that logic in the app, that was controlled using this thing. I think there was a talk earlier. Yes, within the app, but app will call our website itself to get the status from whatever we defined it.
How about Apple iOS?
We were not able to get their team to implement this, so we just used DNS there. Sorry. This. Is kind of possible, but for not our use case, because the first call has to go. We are the ones that handle that first call. You cannot configure that on the browser. You will have to have some very different logic for that. It's like web WordPress or something, but we don't use that.
In this slide, what is the path select? Path monitoring you're using AFD and Cloudflare. Path select from the direct internet traffic to your basis, how you are handling it. What is your fallback or what is the mechanism?
It's just regular internet. So we announce our IPs and it will take whatever route the internet network algorithms tell it to, whichever is the fastest one.
So it's like through the normal ISP provider.
Yeah, normal public internet.
So probably the path 3 route, the latency will be higher compared to other.
Yes, exactly. That's why we use edge providers.
Okay. So that is your like the last fallback mechanism. Is like the
Correct.
board was the
Exactly. So Citrix is actually going to decommission ZXS next year. Well, it's a really good product. It's going to decommission that. So that's why we use our own automation to do the steering and all. Stress testing isn't possible, although we do have mechanisms to do traffic, like load testing. We did load testing, we did send 100% traffic to Cloudflare at a point to see if it's able to handle our traffic. We also tested our failover. So we just turned off cloud AFD aircraft and like a lot of traffic goes to cloud. So we did that for this week and we found it to be stable. 1 minute. Okay, I think we are good. Thank you everyone. Thank you for the time.
Thanks a lot, Varun, for that talk. Again, does bring back a lot of memories from LinkedIn days. Does bring back a lot of memories from LinkedIn days. Thanks for the refresher as well. Our next speakers are from AWS, Bala and Jay. Jay will be joining us remotely. He's on call. So
He's on video. Yeah. Wait, let me put it in full screen.
Let him just this.
Okay. Jay, can you hear me? Jay, can you? Hello. Jake. Jay, can you hear me? Jay, can you hear me?
Hey, hi everyone. Yeah, I can hear you, Bala. Are you guys able to hear me loud and clear?
Yes. We should. So it has to speak. Okay, so this would be on and this would be on.
Can you guys hear me?
Okay.
It's not getting shared, no?
Yeah, that's okay. Okay. Hey everyone, good afternoon. I'm Balchandra. I'm a cloud software engineer at AWS. Me remote with my colleague Jay. So he's a senior cloud software engineer at AWS. So today we're going to be talking about scalable end user monitoring using Amazon CloudWatch. So what we will be covering today is why digital experience is critical, types of digital experience, and also synthetic monitoring using CloudWatch and real user monitoring using CloudWatch. Those are the two offerings of CloudWatch. And lastly, the key takeaways. So before we get started, just a few introductions like on who we are and what we do. So we are from the global support engineering team in.
He is saying that he can't hear you.
Is it now audible, Jay?
Yeah, I can hear you. I think once you unmute yourself, only then I can hear you. Otherwise, yeah, there's no sound on the call.
Okay, now is it audible? Or I think there's something. Yeah, he can't hear us. You can unmute one of them. All of them are connected to the system, right? Yeah.
So if you're speaking,
I I think the audio is not going to the.
Check now.
Jay, can you hear me now? I
cannot.
think. Wait, let me try unmute.
Yeah, I can hear you now, but I guess I don't know if there is an echo for people.
I think there's a.
You're mute.
No, no, I'm at full mute.
You're on mute, right?
Ah,
Your
mute.
mouse on mute.
Okay. But I think when he speaks, it goes to this thing and somewhere in the mic it is catching.
Can you ask him to speak now?
Jay, can you speak now? Not sure.
Unmute and tell him.
Jay, can you basically hear now? Is it audible?
Yeah, I think now it is much better. There is no echo.
You have
So yeah, I hope
speak.
my voice is
Can you speak
also
now?
clear and there is no echo, right? From my end. Can you guys hear me?
Let's do this. Connect from.
You can have a J section and J on the screen or something.
Jay, yeah, we'll try that. Check. Okay.
Let's do this now. What is happening?
It is echoing actually.
Let him
Section when he
use
started,
his laptop.
take over and
Yeah, he can control from there. He can explain. That is a good idea. Right? Just text him always.
Reduce your speaker volume.
No, it is on mute.
This is mute. Speaker. This is mute, right? Now can you speak?
yeah.
This is better. This is better, Bala. If you can hear me, there is no echo right now.
This is not audible. This is not connected. So you can
Can you guys hear me?
He's in the same meeting.
you can enable speaker here.
That is enabled.
Can you ask him to speak?
Jay, can you try speaking?
Hello. Can you hear me, guys?
Yep.
Let's be far off.
Okay. Okay, sorry for that. Yeah, so what I was saying is we are a global engineering team in AWS. So we do provide a 24/7, 365-day support for all our customers. We help them troubleshooting customer issues on AWS. So, and also, apart from this, we do have some offerings for our customers from support side. We do that AWS countdown where we help our customers in basically migrating their prime cloud. So that comes under cloud AWS countdown premium, and also AWS incident detection and response. So that's one more offering where we actively help customers monitor the critical application and help them basically to resolve their critical incidents. And lastly, we have AWS proactive services, where we help customer review their architecture on AWS and give them best practices and all the others, like all the best practices and suggestions that what AWS offers. So, quick question to the audience: do you have visibility into your application digital experience? Like you monitor your application's digital experience? Okay, so one report that is there in the internet is basically 70% of consumers who see the web page as being slow or basically it's not loading in time, so they tend to basically not buy from the online retailers who has the slow page. So this is a report from Unbounce, and also Amazon did a survey and got to know that with a 100 millisecond cost, 100 millisecond delay, we cost it costs us almost 1% of the sales. So this bad customer experience actually affects the business, and these are, we do have some other reports also which say that, and that's why digital experience is important to ensure consistent and great customer experience. So, and also apart from that, like what else you like get from that is that you get an improved user experience, which ensures like your application from the client side it is running smoothly and they have a seamless user interaction. And also this actually turns your customers to be more like users, like turns to be like more loyal towards your application. And also we can also identify some troubleshooting, like in fact we monitor the application, right? So we would you would be knowing in first hand what is actually failing before even customer reports. And lastly, it's a data-driven insight for business to understand how is their application and how is it behaving and what are the where are the key areas that can be improved. So this is why digital experience monitoring is important. And next is the types. What are the types of digital experience monitoring that is there? So there are two types. One is synthetic monitoring and another is real user monitoring. So synthetic monitoring is basically what happens is that there are a set of tools which actually hits an endpoint and then it evaluates the interaction like a user mimic and then gives you a report, and it's best used for like checking the user interactions and for your application's user interaction and the time it takes to basically load for the user. And second one is real user monitoring, which basically the data is collected from the actual user. So the data is collected from the user, and that data, using that data, you can try to analyze the real user's actual experience. So this is, there are two types. So one is synthetic, where basically there are a set of let's say tools that can go and mimic it, and there is real user monitoring, which actually runs on the client side and gets you the data that is required for you to understand what what is your user actually experiencing or looking in. So with these two, we have Amazon CloudWatch Synthetics, which is a cloud offering from Amazon. So we monitor endpoints every minute, 24/7, and then customer can actually use it for API endpoint monitoring, and they can get to know that the availability and latency performance. They can also, this is a outside-in monitoring, which is client-side to server-side. They get full picture of it. And lastly, they have continuous like monitoring. For example, like as I said, start that you can actually get to know beforehand that if your application is actually down or something. So can that run every minute, report to you very early stage, and you can take next actions. So what? Yes, so there are certain, so what it does is, there will be a demo next by my colleague Jay, so where it'll explain what exactly are these Puppeteer, Playwright, and Selenium WebDriver. So there are like, I would say the libraries for, so Puppeteer and Playwright comes with Node.js, and Selenium is Python framework, so which can use like for deploying canaries and test your end user experience. Next is, we also have like, not only just offers you to monitor any application on public or private, it also checks your on-prem endpoints, so it can test it and then give you a report. And it can run on cron or rate-based expressions. Apart from this, we also collect the hard file of each time it basically executes, and it based, like you will get the complete hard file, the screenshots, what was it, the screenshots of the web page, and also the logs. And also it is easy to integrate with the distributed service of Amazon, as AWS X-Ray service. So, and it also gets easily integrated with EventBridge and CloudWatch signals also. We'll have a, so this is the actual, like when you deploy CloudWatch Synthetics, what happens is it deploys the AWS Lambda in your account, which is useful. And this Lambda hits your endpoint based on the cron, rate, or whatever the expression, like the interval that you set, and then it reports back to CloudWatch Synthesis, and then the metrics is uploaded to CloudWatch, and the R and screenshots are in S3. So here launch and get notifications instantaneously, so that you are from first. And also you can also view the R and screenshot that are stored in, and also the logs in CloudWatch. So this is the working of the CloudWatch synthetics. So next one is the demo. Jay. Jake, you can take over.
Jake, you can take over.
Yeah, sure. Let me try to share my screen. Yeah, are you guys able to see my screen? And I think you should see the CloudWatch console. Is that visible to you?
Yes. It is visible.
It is visible.
Okay, cool. Let me know if you want me to enlarge the screen a bit for the audience, just in case the fonts are not visible, so I can make it a bit more, bigger.
No, I think it
No, I
is
think
correct.
it is correct. You can go ahead.
All right. Thank you, Bala. Thanks for the introduction. So as Bala was explaining you like some of the key properties and features of CloudWatch Synthetics, basically it allows you to kind of mimic your end user. So even though, let's say, you are working on a production feature which is not yet GA or available to your customer, you can still go and test it by generating synthetic traffic using CloudWatch Synthetics, right? So let's just see, a quick demo of how you can get started with CloudWatch Synthetics and what are the things that you can get, as a capabilities using this feature, right? And how you can use it in your day-to-day end user experience monitoring. So when you go to the CloudWatch console, you would see on the left-hand side there's a section called Application Signals, and within Application Signals, you would see the synthetic canary option, right? So that's where you can find this feature first of all. And let me just quickly give you an overview of like what you can see in the beginning. So here, we have already pre-created, some of the canaries, and then you can in a one single glimpse, you can see like, okay, how many of canaries are running, how many of them are failing, what is the availability percentage, the frequency of the canary test that you are running, the types of error that you are getting, and so on, right? So this is just an overview of the page. So what we are doing right now in the part of the demo is we are using a sample application called PetSite. uh, you know, so basically this uh, web application is hosted on like multiple platforms. Like some of the microservices are written in Go, some of them are written in Java, some of them are written in Python, and then they are performing different tasks in the backend, right? So for example, there is a search service which allows you to search the pets that are available on your website, and you can click on the search button and it will give you the search results, right? Similarly, there is an adoption microservice that is running in the backend, which allows you to adopt any pets that you want to, you know, take home, right? Basically. So if I click on take me home button, it should direct me to the payment page. All this data is of course dummy data, but just to show and give that experience. So you can click on pay button and you can easily adopt a pet, right? So this is the sample application basically that we are using for the demo, right? So what I'm going to do is I'm going to basically perform a very simple check. So let us try to create a canary resource that will allow us to monitor, this pet site application, and we would like to monitor the uptime of this particular canary, right? So when you go to the create canary button page, you can see a bunch of options, of course, to kind of create the resource. So to start with, let's say if you are very new to the canary feature, so we give you some blueprints. Blueprints are nothing but as, just some pre-created templates, to get you started with them. So if you are not very well aware about this feature or don't know how to actually use it, you can easily start with, using any of these blueprints, right? So let's say we just want to do an uptime monitoring of this particular web page that we have. So I would just select the heartbeat monitoring blueprint, I can give a name to my canary. So let's say my pet site app, and then I need to give the URL, right? So HTTP slash slash and the domain name, right? And then that's it, right? So if I just do this, and as I'm using the blueprints, it will automatically generate a script for me. So this is nothing but a Node.js based script, which is using the Puppeteer framework in order to generate this test and perform all these user actions on your on your behalf, basically, right? So you don't need to even write any piece of code. Actually, you can just by providing the URL, you can fairly get started. If you're not very well aware about, and of course, right, we also give you an option to kind of go and write your own script. So, for example, let's say if you want to use some other framework. So let's say I want to write a test in Playwright, which is again another well-known framework to do synthetic testing. I can go and write my script and then I can use it for my testing. So it's all very modular in terms of how you can write the scripts and what you can do with it. But just in case if you're very new with it, you can fairly get started with this blueprints. So we have different blueprints like you can do API testing. For example, if you have an API, you can define the API request method. Let's say I want to post something onto a particular API endpoint. Let's say slash API slash v1, and then I can give the the request header details and the payload that I want to send to the API to verify certain behavior, and then I can save it. And then what the canary will do, it will keep on hitting that API endpoint with that particular uh, the payload and all the headers that you want to send, and then you can get the test result out of it. So yeah. So again, coming back to the heartbeat monitoring, so I will just keep the URL as it is, and then you can also basically specify whether you want to take screenshot. So screenshot will allow you to kind of uh, go back in time and see like, okay, for this particular test, this is how the page got loaded, and you can compare whether certain elements were giving some errors or some elements were not working and all those things. You can easily identify it from the screenshots of your web page that are being taken out of these tests. And then obviously you can like kind of run these tests at your own requirement and at your own schedule. So let's say I want to run this test every 5 minutes, I can do that. I can also do like, if I want to just run a daily at a particular time, I can also select that. Or I can define a cron expression and, make it a little bit more complex to schedule, the canary test. And then I can also, configure that, or you can run it once as well, right? So let's say in your CI/CD pipeline, let's say at a CI stage, maybe if you are kind of pushing something and then you just want to test it once, kind of like as soon as the developer pushes the new code changes, you want to go and start this canary just once, and then based on the result, you kind of take the code forward to the next stage in the pipeline, right? So these are some of the use cases that you can do, based on different scheduling methods. And then obviously, like you kind of create alarms. So when you create a canary, you get certain metrics out of the box. For example, the success percent, the duration of the canary, or HTTP errors like 4xx, 5xx errors. All these metrics get, are emitted out of your canary, out of the box. And then using those metric itself, you can directly create alarms on top of it. So let's say I want to get alerted and I want to alert a particular team as and when the success person gets lower than let's say 90% or let's say 99 or 99%, right? Whatever threshold I want to set for the period of let's say last 5 minutes, 1 minute. Again, it depends on how you want to configure it, and then that allows you to kind of like page or alert the team who is owning that particular resource, and they can go back and see, okay, what went wrong with your web page, and then they can probably try to fix it, as and required. And also so I think one of the slides we mentioned that Canary can test any endpoint that you have, provided you have the network connectivity to that endpoint, right? So it can be a public endpoint, or it can also be a private endpoint, let's say within AWS or any other platform as well. Also, it can also be your on-prem endpoint using, let's say, you are connected through VPN and all those stuff. right? So for that, we give these VPC settings. I will not go deeper into it, but just to let you know that you can test and connect to any of the endpoint as long as you have the network connectivity to it, right? Be it private or public endpoint. And then it also integrates with AWS X-Ray. So once you enable this, you can see a clear trace map of the synthetic client generating the traffic to your application, and then you can also see the backend services, like how they are performing and how this is all connected together through the AWS X-Ray console as well. And we will also see in the demo as well. So these are all some of the configurations that you can do. Uh, and once you create it, obviously, you will get something like this. So I already have some pre-created canaries. So let us quickly have a look at, so I'm doing a test, uh, and I'm verifying the search functionality of my application, right? As you see here. So what I'm doing, I've scripted the canary test in such a way that I will randomly select any one of these options or the web page element. And again, for the color as well, I'll randomly select anything, and then I'll click on search button, and I'll verify whether the search is working or not, right, on my application, right? So as you can see, to start with, you on the very left hand side, you see that there is a summary of issues that has been detected with your canary in the past, right? So, from there you can quickly see like when and how, certain issues had occurred. And you can also try to derive, frequency of the issues that are occurring, whether it's a frequent issue or is new issue or something like that, right? So it gives you a quick summary of, what kind of errors you have seen with this particular test. On the right hand side, you get these metrics. So basically, red means that particular canary test has failed in that particular point in time. Blue means it was 100% successful. So it's kind of like giving you idea about, when and where, canary test failed. And then let's say if you want to particularly see, like, okay, at this particular time it has failed. Now I want to go deeper into the analysis, right? I want to see what happened with my website or web page, and I want to figure out, what went wrong and how I can fix it, right? So once I click on this metric here, it will take me to these uh, other sections of the data that the Candy connects, right? So it will show you like, okay, I was navigating to my website and that particular step has itself failed. And it will give me a stack trace of the error that has been received while performing the test, and the duration and how many screenshots it captured while doing this test, right? So now once I move to the screenshots page, I could see the exact page screenshot that has been taken while performing the test. So here you can clearly see that while loading or while navigating to the website, it gave me this error, right? Which is like this error page. So basically, if you are a user, you would have also seen this page. And just like a user would see, you are able to see this at your own end in your Canary console, basically, right? So this gives you an idea about what kind of error you had faced while testing, and you can then work further to kind of fix the error, right? So along with the screenshot, we also capture a very detailed level of logging for your canary. So here also you can see that there are different levels of logs. So for example, info, warning, debug, and error. So from error directly you can see that what kind of errors you had faced, and then you can further debug the issue based on the logs. Right? So everything you can see that it's all in one single place. You don't have to go to other places to kind of correlate things and try to perform the root cause analysis and debug the issue, right? And finally, we also capture, the HAR files. So HAR will give you a waterfall diagram of how the requests were, being made, from your web application. So there are certain actions or certain URLs that you are calling from the backend. So you will get a waterfall diagram of all those things. And for example, here you can see that, at this particular process, you had spent around 310 milliseconds, right? Which is like the most of all the process that you're performing in the backend to kind of like fetch certain elements from, certain other endpoints, or let's say you have some images stored in S3 bucket. So you can also see like when you make the API call to the S3 bucket, how much time it is taking to kind of, load those images. And then based on that, you can try to, work with your teams to make sure that where you can improve the performance, how you can make this particular process faster so that, the user experience is enhanced, right, at the end. So this is what you get when you create a canary. Let me quickly the metrics that we collect. So I told you like there are certain metrics that are collected out of the box for you. So these are when you go to the monitoring section, like you can easily see the duration metric, how many times the canary has failed, was there any 4xx or 5xx issues, the duration of the each canary test, and then the success percent, like when the canary has failed, and so basically you can use all these metrics to kind of create alarms again, which is very common practice, like to get alerted, to the respective team. Okay. So yeah, that was it. I mean, we'll take probably the questions at the end of the session. So yeah, if you have any questions regarding synthetics, let us know. I'll hand it over to Bala again.
Okay, thank you, JD. Okay. All right. So thanks, Jay, for the demo. So since now let's move on to the next offering, that's real user monitoring of CloudWatch, or what we call in short as CloudWatch RAM. So this actually, as I said earlier, real user monitoring tools actually collect data from your real users, and they report to they gather data, and using that data you will have more insights into what your user is experiencing, what errors they are seeing, and and what you can actually think of, and also it gives you the JavaScript errors also, so that would help you understanding if a functionality is not working at a user level. So this again, CloudWatch RAM is so this is a client-side telemetry. So we would and also this correlates with the other resources. So you would see in the demo that how it shows how a user to which web page they are jumping, and how they, so you get to see the entire user session, and so it helps you to measure the impact of your user, to understand if a user is basically getting impacted, and the logs from these for returning to the CloudWatch RAM would help you to create alerts, and then send you alerts beforehand. And lastly, debugging is made easy, since basically you are getting data from the real-time user from their end. So this would help you debug your application from your user end much more easier. So just few stuff about CloudWatch RAM is we collect something called Web Vitals. That is standards. That Web Vitals would give you the understanding of how the page is, and guidance on how to improve your page. So these are the metrics that we collect: largest contentful points, first input delay, and also cumulative layout shift. And also we calculate the APEC application index score. And next we also give in this CloudWatch RAM, it also collects the navigation and timings that your users use to click, and also basically the page view count, JSON errors that I said, and also the sessions. You can also add custom metadata to your events that you send, and also this gets custom events is also supported. And lastly, it is again easy to integrate with the AWS X-Ray and CloudWatch and application signals. So this is about just a brief about RAM. So, and coming to the working, so we have a web browser, and here, so as I said, we collect data from the end user, right? So what happens is within the web browser, so there will be you can within your web page that is served, right? So you can have a JavaScript or HTML small snippet that actually collects these data, and then that data is basically sent to the CloudWatch RAM endpoint. RAM analyzes data, and then you get the metrics, which can be used to again configure alarms and get notification, and also you get the logs as part of what is collected, which can be used to analyze and debug issues. So I'll call upon Jay. So just for the demo.
Should I take it over, Bala?
Yeah.
Okay, cool, thanks. Okay, so let me start my screen sharing again. Yeah, just a quick confirmation. Are you able to see my CloudWatch console?
Yes.
Yes. Okay. So yeah, thanks Bala for the quick introduction of the CloudWatch real user monitoring, or you can say CloudWatch RUM feature. So let us quickly take a look at how you can get started with CloudWatch RUM, and then uh, so just to create a very basic difference about rum and synthetic is like with synthetic, as the name indicates, it's something like you are generating, at your own end, like kind of like a user traffic, but it's not your actual user, right? But it helps you to kind of baseline your web page performances, and it helps you to kind of like proactively identify any issues before any actual user goes and complains about it, right? So that's what synthetic is. But then with that, you also kind of need an actual view of, how your end user are experiencing your web page performance and everything, right? So that's where CloudWatch RUM comes into the picture, right? Like it actually goes and collects basically your user's browser's performance data, and it will collect it back to the CloudWatch, and from there you can see, a very good dashboard of some good metrics that I'll again like show you. But just to create that very brief difference, like where you can use synthetic versus where RUM will be useful, and then obviously they both complement each other, right, together. So again, when you go to the CloudWatch console under application signals, you will see the RUM feature. So once I click on it, I can get an overview dashboard first of all to kind of whatever things that I'm monitoring. It will give you a quick summary of, like what is the how many page loads has happened, right? Or what is the average page load speed time? How much time basically it is taking on an average to load my application page. AppDex score, right? This is pretty interesting. So AppDex means like your application performance index. So this is kind of like an industry metric that you will see, which is which is like very which is kind of like give you an identifier like, okay, how my web page is performing, right, in a very simple terms, right? So it is scored like 1 out of whatever you score. So right now you can see that for my application, the Apdex score is 0.84 out of 1, right? And if you want to look at the formula, I mean, there's a fixed formula for it to like how do you go about calculating it. You can always go and look it up, but right. So this is what you also get on the overview page, like how your application is actually performing from a user's perspective, right? From your actual clients, So you get a fair idea about the performance of your application by just looking at this one particular score, right? And there are like categorization of AppDex score. So let's say if it is greater than 0.9%, so zero point 0.9, so that means your performance is very good. Let's say if it is between zero point 0.7 to zero point 0.9, then it is average. And then if it is below that, then it's poor performance, right? So from that score, you can categorize how your application is performing. Again, some other performance metric you can get from an overview, and we'll look into all these into details, right? So let us first understand how you can create CloudWatch RUM resource and how you can get started with the monitoring of your end user performance data, right? So you just have to click on this Add App Monitor button, and that will take you to the configuration page. Of course, you'll have to give a name to this resource. So I can give like Fed adoption uh, test, whatever, right? And then you'll have to give the domain name which you want to monitor. So for me, obviously this is kind of like a load balancer domain, but here you will actually enter your website domain like www.amazon.com or amazon.in or whatever, right, you have. And you can also mention whether you want to monitor all the subdomains of that particular web page or domain that you're using. Next part is, so we talked about RUM helps you to collect, signals or telemetry data from your actual client. So what are those data, right? So one of the key data that it collects is the performance level metrics from your end user browser, right? So which is called as performance telemetry. So as you can see that this is all like configurable. So let's say if you just want to collect the performance data from your end user and you don't want to collect, let's say, JavaScript errors or HTTP errors, you can just disable them and you can configure the RUM resource in such a way that it only collects this data. But if you want to collect all of them, you can just select them and that's it, right? You can, and it will collect everything for you. What is other data? Other data is nothing but apart from all these three data. So all these data basically get pushed to RAM in a JSON payload or JSON format, right? And in that JSON, you have different key value pairs giving you a different aspect of the performance, the errors that you have, right? Similar to that, you can create your own JSON events to push your own business, you can say logic or some kind of information that is not available through RAM, but you still need it for your business metric or anything else, right? So you can create your own JSON event and you can pass it on to RAM, and we will also show you that as well, right? And then there's an option to sample, right? So obviously, like this helps to kind of you know the reduce the cost of using CloudWatch RAM. Let's say if you don't want to capture 100% of your user traffic, you can dial it down to, let's say, maybe 80 or let's say 70, right? Whatever you want. So that what it means that out of 10 sessions, it will collect data from 7 user sessions, right? So this is how you can basically play around with the sampling, frequency, so that you make sure that you are playing within your cost boundaries, right? Just in case. And then, so by default, CloudWatch RAM stores your user data or user performance signals for 30 days. But if you want to extend it, you can choose to configure a CloudWatch log group where all these performance related or HTTP errors related JSON payloads will get stored. So you can always set a customized retention on your log group, like you want to store it for last 1 year, 6 months or whatever, and you can go back in point in time and you can query those logs directly from CloudWatch to kind of perform some analysis or anything that you want to figure out from the past, right? So that is where this integration with CloudWatch logs is pretty useful. Uh, and then you can select the type of authorization method. So basically, you can create a Amazon Cognito identity pool, so you can use your own identity provider to kind of authorize the RAM web client to send all this data to CloudWatch, right? Basically, right? So that is why you need this authorization, and then you can also configure, like you can either exclude certain web pages that you don't want to monitor or include certain pages and all those things. You can filter out basically. And again, this helps you to save some cost as well, right? Let's say there are certain pages which are not that critical for your business. You can exclude them by, giving the entire URL or just the path of that particular web page, and those will be excluded from being monitored through RAM. And again, this also integrates with Amazon X-ray, so you can see in the X-ray map that how it looks like, like how it connects to other backend services, and you can see a single view of starting from the client to the backend service and how things were being performed, or what was the performance at each particular layer through the X-ray, right? So that's how you create an app monitor. I already have one, and like uh, just to show you here. So I have this pet site RAM app monitor that I've already created just to generate some traffic so that I can show you some of the key things on this dashboard. So once you go inside this app monitor, you can see that there are different tabs, and each tab will give you a different kind of data or insights into your end user experience, right? So for the very first thing, what you can do is right now, this is all an aggregated view of how all your web pages are performing, and how what is the error rate or what is the page load time and everything. But you can click on this pages button, and then you can see all this data that I just showed you on this overview page for each and every page as well, right? So it can go up to that granular level as well, right? So if you just want to investigate a performance of a certain page, you can always select that and see the data for that particular page as well, right? So that's pretty handy when you want to like narrow down the issue for a particular page rather than seeing an aggregated view and then able to figure out like where the issue was, right? So on the performance page, you can see various performance data that we collect. You see this heat map so let's say if I just do a 1 week, although I don't have data for the last 1 week, but you can get a sense of how it will, be able to show you, right? So here you can see that we are showing you a heat map of average page load time day by day, and you can see this nomenclature where if the page load time is less than 2 seconds, then it's a positive experience. If it is between 2 seconds to 8 seconds, it is a tolerable experience, and then if it is greater than 8 seconds, it's a very frustrating experience for user, right? So from this heat map, you can quickly get an idea about like at which particular day or hour, you had some bad performance being observed at the end user, right? So right now, our application is not that good, to be honest. So it is showing, a tolerable experience on most of the days, right? So we'll have to probably work on it and improve this basically to make it a very positive experience, right? Yeah. So coming back to the next thing that you can see on this page, there's something called as Web Vitals. Again, this is an industry standard when you are talking about digital experience monitoring and figuring out what is your web page performance. So we give you these web vitals out of the box. So there are three main core web vitals, which we call it as largest, contentful paint, first input delay, and cumulative layout shift. There are other web vitals as well that we also provide you with around, but these are like the three core, you can say metric that you should always monitor in terms of, knowing your page performances, right? And then you kind of get to know like at which part of your web page loading the most time is getting spent, right? So for our application, it's kind of like while downloading all this content like the images and everything, we are spending the most time, or the user is seeing the highest delay in this particular step. So we probably have to go back and see how we can again improve this with our application. Next is the error tab. So error tab will give you an overview of what kind of errors your users are seeing. It can be an HTTP error or it can be a JavaScript error, right? So basically using this, so right now you can see that so in this application we are generating this random error event. Basically this is a JavaScript error that we have randomly injecting into the web page, and that is what being getting captured, right? So let's say if I want to go deeper into like which users are facing this error. So I can go into that and then I can see all the details of the error that has been received for this particular user, right? So let me just show you, how it looks. So I told you that all these data is being sent as JSON payload. So this is how you get, right? So you get a lot of information. So you can get what is the browser name, what is the browser version, what is the OS of the user, which from where they are running the browser, what was the page for which this error was occurred, what was the domain name, and at what time it occurred, from which location the user was trying to access this web page and where they actually faced an issue, right? So you get all these minor details about your end customer or end user based on which you can identify certain edge cases or issues that are only, let's say, prevalent for specific browser version or specific browser type, or let's say specific location of your user, right? So all these things you can narrow it down by understanding and looking into these insights that are being provided through the RAM monitor, right? Similarly, you get a breakdown of, I showed you already, but let's basically another dashboard of a breakdown of how the experience looks like from different browsers and devices, right? So I can see that like most of my users are using either Chrome or Firefox browser, where the page load time is pretty same, but I could see that maybe on the Chrome browser, I see more errors as compared to the Firefox browser, right? So maybe there is something wrong that I need to probably go and check, with how my web page is getting loaded with Chrome browser as compared to Firefox, right? So I can do these kind of comparisons, and I can also see the data by devices as well, not just browser. So then I can understand what is my user base, right? Like, are they using their a desktop browser to access my website, or are they using a mobile phone to kind of, access the website, right? And based on that, you can again see like how the web application is performing on a browser, on a desktop-based browser as compared to a mobile-based browser, right? So that also you can compare through the data that we collect for you, right? And the next thing that I wanted to just show you quickly is like, with the user journey. So we also capture user session details. And then based on that, we kind of create this graphical map for you. I hope you are able to see it clearly. Let me make it a little bit short. So you can see that starting from the home page, what path a user is taking or what is the user journey within your application. So for example, let's say if I'm running an e-commerce website, right? So obviously, user will first land on the home page. They might search for some products that you want to buy. They might go and look at certain products, and finally, when they really like a product, they will probably add it to their cart, or directly buy from that page and make payment, and that's it, right? So this is kind of like from the home page to making a payment. This is kind of like a particular user journey, right? For your client, right? So this helps you track this user journey, like how your users are accessing your web pages or your applications, and then based on that you can again create some funnel, or even understand, let's say, if most of the users are dropping at, let's say, the add to cart option page, that means that they are ultimately not getting converted and they're not making the payment, and hence you are not getting the revenue out of it, right? So there's something wrong with that particular stage of the user journey that you need to go and fix it, right? So this map will give you that idea about how how the users are accessing your web page and maybe where they are dropping out on certain pages or certain workflows, and you might want to go back and fix it, right? Something like that. So yeah, that is all about the data that you can see from the CloudWatch RAM, and there are lots of other metrics as well that we collect for you. It's just that we kind of show you the most important ones, and then if you want to see some other things, you can also see them. Some other metrics that we collect out of the box for you as well, right? And then one more thing that I just wanted to show you, like, so actually, how do you go and enable this, right? That's very important, right? I should have covered it in the very beginning, but apologies for that. So let me just quickly jump onto that. So once you create the RUM app monitor, you kind of get the sample code or script. So let's say if you have a React-based web page, or which is using the Node.js libraries and everything, you can get this core piece of code that you can go and add it to your React code, and that's how it will go and collect all this telemetry data from your browser. Or let's say if you just want to make it very simple, so you can go to the HTML tab and it will give you a JavaScript, right? So what you need to do is you need to copy this JavaScript and you need to go and paste this JavaScript in your HTML page where the head section is, right? And you need to paste it under the head section. And once you do that, next time when any user will load that particular HTML page, this JavaScript will be executed, and then all the performance data that we just saw, from the RUM dashboards, it will be collected and it will be pushed to CloudWatch, and you get to see all this, useful insights on the dashboard that is being collected from your actual end user browser, actually, right? So let me just quickly show you how we have done it here as well. So on this particular page, if I do a right click and if I do a view page source, right? So I can see, let me make it a little bit big. So you can see that under the head section of my HTML page, I have entered this script section. So this is nothing but the same code that I showed you here, which I have pasted onto the head section, and that's about it. Once you do this, once you redeploy your website, it will start collecting these telemetry data, and this is all configurable as well, right? So you can, let's say you don't want to measure the errors, so you can just remove the error from the configuration, and it will just collect performance and HTTP related events for you, right? So it is very configurable. If you go and visit our documents, you can see what all things you can change in this JavaScript. But this is the by default script that we kind of provide to our customers, and then obviously they can go and change it as per the requirement, right? So yeah, that is how you go and enable this actually. And so if I talk about, let's say, a multi-page application, so you need to go and inject or insert this JavaScript in each of your HTML pages, right? So for example, if I have this page called slash pet list adoption. So I need to also go and inject that JavaScript in the head section of that particular page. So for each individual page that you have, you need to go and insert this JavaScript in the head section of that particular page, right? Otherwise, it will not go and obviously collect data from all the pages that you want to collect, right? Yeah. So yeah, that is just small thing that I just wanted to cover. Uh, I don't know how we are doing on time. Otherwise, I just wanted to show you one quick thing. Bala, are we good on time or we are over? I just wanted to do a quick check.
No, I think
No, I
2 minutes.
think 2 minutes.
We need just one section. He needs to show one thing. Just 2 minutes. Yeah, you
Yeah,
can
if
go
we are
ahead.
over, it's okay. Like I think I've
Good.
covered most of the things that I wanted to cover, but it's okay. Like you can take it over and yeah.
No, Jay, you can
No,
cover
Jay,
it.
you can cover it.
You can show the
Okay,
logs
You
part.
can show the
cool.
logs
Then
part.
just one quick thing that I wanted to show you. So I told you that there is a integration with CloudWatch logs, right? So how this can be useful, I just wanted to show you in a very quick way. I won't take much time. So yeah, just bear with me for a couple of minutes. So once you enable the CloudWatch logs integration, your RAM performance data is basically stored in this kind of particular log group, right? So it starts with AWS slash vendor log slash RAM service, and then the name of your app monitor that you have created and some random ID, right? So that's the log group basically. So what happens is, let's say if I run so I'm basically using CloudWatch logs insights query to kind of query my RAM data logs. Just in case if you're not aware what this is, this is kind of like a query language that or query UI that you provide to a customer to query their logs that is stored in CloudWatch, right? So as you can see that all like I'm just listing out the first 10,000 events that I have captured, and if I just expand them, you will see the same JSON event that I showed you just few moments before, which had some useful metadata and information about your end user, right? And the very good thing about Insights query is because it's a JSON payload or JSON event, you can see there's an option called discovered field, right? So by default, CloudWatch logs will discover your JSON keys basically, right? So you can see that all these JSON keys are being basically why I'm showing you this is now using these different JSON keys, you can filter your data to slice and dice the information that you want to see, and you can write your own complex queries to kind of derive the insights, from the RAM data. So another thing that I just wanted to show you. So let's say if you are very new and you really don't know how to query these logs. So we also have a GenAI based query tool. So basically you give a prompt to this query generator and it will actually generate a logs insights query like this for you. So I will just show you a quick demo and then I'll wrap it up. So let's say you don't know like what kind of fields you have in the RAM logs, but you have a goal to let's say give me the uh, top browsers by browser version, right? So I just want to see that what kind of browsers my users are experiencing and what is their version, right? So I can just quickly give the simple prompt to this query generator tool, and then it will try to understand this prompt and try to give me a query. So right now, if you see that this query tab has changed, right? So earlier it was the default query, and now you can see that it is basically doing a count by the browser name and the browser version, right? So metadata.browser name again, it's a like a JSON key within your RAM event. So it directly was able to pick those key fields that we should be querying, and then it created this query for you, right? And probably I can limit to one. And let's just quickly run the query as it is, right, and see what kind of data you can get, right? So as you can see that right now there are not much. I mean, you can see now the breakdown, right? So we asked for give me the top browser by the browser as well as the browser version, right? So this is Chrome headless. Headless means like this is nothing but traffic being generated from the synthetic canary actually. So canary under the hood loads a headless Chrome browser. So that's why you see Chrome headless. And then the the version of the browser that the canary is using actually, and the count of, the request that it is sending. So let's say probably if I expand it to last 12 hours, I might see some more browsers. I don't know, right? Let's see if we get some more data. Maybe not right now, but yeah, just to show you like how easy it is to even get started, to query your RUM data through this logs insights query, and you can always use this query generator. It's kind of like an assistant to you to help you write the query that you need, even if you don't know anything about, let's say, the insights query, or you don't know about what kind of fields you want to query or filter out of, right? So that is something that I just wanted to quickly show you. Yeah, cool. I think that was it from my side. Yeah, thanks, Bala. You can take it over.
Thank you,
Thank
Jay.
you, Jay.
Okay, guys. So that was the demo for CloudWatch RAM. And so the key takeaways we are at the end. So basically, we like synthetic monitoring can help you identify the issues before the users are impacted. So the canaries would be running every minute. So your digital end user experience, whatever the end user is seeing, you would get to see beforehand. And also the real user monitoring can help you to actually get the end users like basic experience, in the sense the exact errors that they see, which is something easy to debug, and also it's real-time data. And overall, with digital experience monitoring, you can help you can actually get a better customer experience and achieve your business success. So, as I said in starting, that most of business due to bad customer experience, there is an impact in business which can be actually mitigated with digital experience monitoring. So one last thing is, any questions? Anyone wants to? The RAM? So the RAM cost is quite different. It's not so it would be on the user part. I think that's like you would the data that is collected from the that flows in. So, but I think the pricing page should have the exact details on it. But it's more or less what you mentioned. Browser?
So the users maybe differs, right? Someone may use Chrome, someone may use Firefox.
Huh. It works on yeah. So this like you want to see like which browser your end user is using, right? That's the question. Yes, that's available. Yeah. You can get to know which like your end user is using, and also the top one. So in the demo what Jay showed, so that was the part. So you can actually, with the data that Drum collects, right? So if you collect a full 100% of like all the sessions that your user doing, then you get the full data. So otherwise you can like minimize the data that is coming into RAM at the RAM level, and also still all the data would be collected from it does not matter like is it Chrome or Firefox, it comes from all, and you can get the detail where exactly how many of your users are using Chrome, how many of your users are using Firefox. So that data can be using log insights, you can get it. Which one? CloudWatch. Yes, this is part of CloudWatch. This is part of. No, so this section is what CloudWatch offers. So this RAM, this real user monitoring that is there, that is what CloudWatch offers, and even Synthetics is CloudWatch part. No. This is your end application. So your end application. So what in the demo is that the application was running on a container, and I think the observability workshop that I showed you. So that application is running somewhere else. So CloudWatch just collects the data and stores it here. So whatever basically the synthetic, the canary is executed in CloudWatch, it basically collects that data. So in synthetic, the Lambda runs that collects the data and pushes to synthetic, and then you get the screenshots, R file, and also this one. And also the RAM is also similar to that, where you have the logs that is also being coming from an application. So
In your architecture, you run that RAM metric on top of Lambda, right?
no, RAM is not on RAM. RAM is on like this. Rum gets it from the web end user. Client side, yes, correct. So you would have the HTML snippet which contains JavaScript which is the header file. So that generates something and sends to Rum endpoint. This is coming from the end user itself. So the end user sends it to CloudWatch. So you're asking like this collection part, right? Correct. And it has an endpoint for Rum. In that's there. The Rum endpoint is there. Yes, yes. So basically that yes. So the HTML inject which contains it has the code for entire one. Huh? Yes, there would be a lambda in your account, and which would be like you can see this. So this would be running the script. So basically, you had Node.js, Python. So this runs the canaries. So this runs the lambda to collect data and gives you these metrics and logs. So this is basically just for like you can configure all the actions that you want. So you can actually tell your user like this one. This is the CloudWatch service. That's it. So you don't get to see what lambda. No, CloudWatch, that's basically a service that we offer in CloudWatch. So it's not actually a programming thing or something. So this lambda, what it deploys, so this lambda code, okay, so you would have Node.js and Python, like it's a frameworks. So we support Puppeteer, Playwright framework of Node.js and this one, Selenium of Python. Thank you. Okay. I think if there's no more, yes. Right? Any other question?
So on AZ failure, this is also failure.
AZ failure? No, I don't think. Let me check.
Because typically we do from an outside kingdom or usually data from there. They are down.
So like you are saying that. Okay. So the question is that AZ failover would impact synthetics or Rum, right? You're saying? No, I don't think so. Jay, can you?
Yeah, it is not a AZ based resource actually, so you should not see any impact just in case an AZ would fail because I mean, the resources are just logical resources that we create. So yeah, it should not be affected by any AZ downtime or something like
Easy
that
downtime should not affect.
for both Rum and synthetic calories.
Thanks, Jay. Thanks, Jay. All right. So these are some best practices from AWS. So observability best practice. You can scan the UI, you get the web page, and also you have the workshop that we demoed. So you can also like basically go and try it out in your AWS account. So that's workshop 1 for you. So that's it from our end. Thank you.
Stream is still there. He will announce and distribute those accolades and then we can.
Alright, thanks a lot, Bala.
We can make it big then.
And guys, that's pretty much what we had for the Tech Talks today. But it takes a community to see this Meetup group alive, and it takes speakers to have these meetups up and
He has to drop actually.
want to quickly call up all our speakers for today on stage once.
Don't watch. Don't watch. No, I didn't remove. It is connected.
Great. We have a small token of appreciation for you guys. You just give us a moment, we'll just quickly hand it over, and yep, the snaps should keep on coming. Cool. Given that the talks are done for the day, definitely folks feel free to hang around, continue the whole networking, which is the whole idea behind all of us coming together on a Saturday. It's again from our side, which is myself, the team, the leadership at Wayfair. It's great to have everybody around, and hopefully we'll keep on bumping each other on the various means of communication, which is social media and everything else. That said, we bring the 53rd LSP India Meetup to an end, and since this is the last meetup for LSP for this year, wish all of you a very happy new year, and for those who enjoy the Christmas spirit, this is a good time to have some Christmas cake. So yeah, thanks a lot everybody, thanks a lot to those who tuned into the live stream, and well, what is a tech meetup without hiccups? So yeah, they were in here as well. But the good part, at the end of the day, we just got through it, and we have what we would call a successful rollout. So thanks everyone, really appreciate it. Thank you.